So I hope all of you all can see my screen. So let's get started. So as we are waiting for others to join, let me just quickly show you all two tasks that I have added to the bot with which we were working yesterday. One of the tasks is an open account task. I have created this to show you all some of the entity types which you can use in the dialog tasks that you are building. So this is a task. The purpose of this is like the user can ask the bot that I need to open a new account, and the bot prompts the user for a few details and saves these details using an API call into the table, mock API table with which we were working yesterday, and comes back with a response. Now, there are two major points why I've created this task. One is to show you all some of the entity types, and the other is through a script node, how to implement business logics. You can do that through a logic node if it is a multiple level if else if condition. You can do it through a logic node, but you can also do it through a script node. So through a script node, how you can implement this kind of multi-level business logic, that is what I have tried to discuss here. So let's get started with this task. So you can see the first entity is the account type, where the bot prompts the user for the type of account he wants to open. Let me just show you all the execution before we discuss the task. So we go for the open account task. So you can see it presents a choice between two types of accounts, savings or checking. Now, if the user selects the savings account, okay, so you can see the entity picks up the value of savings. It asks the user for the primary account holder name. So let's say the user provides the primary account holder name. It asks for the opening balance. And when the user provides an opening balance over here, you can see that it comes back with two messages. One informing the user that your request for new savings account, that was the type of account the user has selected, has been raised successfully. What else can I do for you? And this row is added into the table, okay, that is the mock API table, as a new row over there. Okay, so let's see how it is working. So when you want to present a choice to the user, yesterday we have seen a confirmation node presents a choice of yes and no to the user. But there might be a lot of situations where you need to present, different choices to the user. So here the type of entity that I have used is a list of items. Okay, so when you make an entity a list of items, you can define a list to be displayed to the user. So once you select this is the type of the entity, you get a settings button coming up over here. Click on that, and within this settings, you can define the list to be displayed to the user. Now there are three columns over here. One is the display name, the value, and the synonym. Display name is how the choice is presented to the user. I'm presenting the choice as savings and checking. I can also present it a little more descriptive way, like maybe a savings account and checking account. Okay, so it's your choice how you want to present, the display the choices to the user, maybe descriptive names over there. Savings account and checking account. Now, the synonyms column are the possible values the user can provide for this particular, display name. That means now I'm displaying savings account and checking account. But actually, if you see, the user is going to say that word account is not required. Okay, so internally, if the bot knows that the user has said savings or checking, it's enough to continue with the flow. Okay, so that what you display to the user, you may not use the whole of it in order to define your flows internally. Okay, so savings account, checking account is a very descriptive way of presenting the choices, but the word account is not required. So we can just internally say that if the user, says savings, that is more than enough to understand what type of account he wants. Or the user says checking, then it is good enough to understand what kind of account he wants. So the synonym columns are the possible values the user's utterance, in the user's utterance, or when the user makes a selection, what is the possible values that will be picked up by the bot. Okay, so that we provide in the synonyms column. The other use of the synonyms column is, now today the user can say, I want a current account. Okay, like in India, we refer to a checking account as a current account. Okay, now the bot should have the intelligence to understand that when the user says current account, it actually means that he wants a checking account. So this intelligence of the bot, that current account actually means checking account, we can provide that, we can build that intelligence by providing current as a synonym, sorry, by providing current as a synonym of checking. Okay, so these are the possible values the user can provide for this particular choice. Either the user can say checking, or the user can say current. Current also means the same as checking. But when the user says any one of these, what is the actual, the final value that gets stored within this entity? The entity is account type. So what is the final value that gets stored in the entity? That is what you define in the value column. So this is the actual value that will be stored within the entity. So today, if the user says, I want a current account, you will see the account type entity will actually hold the value of checking, because that is the final value that gets stored. Okay, so these are the three columns that you need to provide when you have a list of items type of an entity. Display name, what is displayed to the user, it can be a descriptive name. The synonyms column are the possible values for that particular column. Here you can provide the synonyms that can be present in the utterance of the user, which mean the same. They are synonymous words. And the value column will be the final value that will be stored within the entity. So you can define your list in this way. There's no restriction. You can define a big list, okay, of items over here. And once you complete defining the list, save it and come out from here. Is it clear to you all? Any questions on this? Okay. So we come out from here, and then the rest of it remains the same. That is the prompt for the user. Okay, so the prompt that will be displayed above the list of items. Okay, so I have provided a single prompt, that is select your account type. You can provide multiple prompts like we have discussed in yesterday's session, and one of those prompts will be picked up at a random and displayed to the user along with the list of choices that you have defined. Next is you have to ensure that the list is displayed to the user. So enable the display of the list of items or list of values. By default, it does not display the list of values, but you have to enable it over here. And finally, the error prompt, if the user says anything that is not defined in the synonym column, okay, the user provides any value which is not specified in the synonym column, then the error prompt comes up and the bot reprompts the user to enter the value from the list. Yesterday, we have also discussed how we can restrict the number of retries. So by default it is 5, which is maximum, but if you want to restrict it to 3 times or 4 times, you can always do it from the instance properties of this particular entity where you have the number of retries. Okay, so that is the first entity that I have configured here. The second entity is the name of the person. So as the name of the person will be a noun, the type of the entity is a person name. I have shared the link to the documentation yesterday, which gives you the details of all the different entity types which are available on our platform. Please go through that documentation because it will help you to understand what type of entity to use when you are creating your dialogue tasks. It's a very essential knowledge for the bot builders. So here I have used the person name type of entity. And finally, balance, of course, will be a number. So it is a simple numeric type of an entity. Now, I want to implement a business logic over here. That is, if the user selects the type of account as savings, then the minimum opening balance should be above equal to or above 1,000. And if the user selects the account type as checking, then the minimum opening balance should be equal to or above 500. So you have multiple, business logics with this. How do you implement that? Because once the user provides a value for the balance, you need to do that validation. One way is, since this is a multiple level of if else if conditions, you can do it through a logic node. Okay, yesterday in yesterday's task, I have shown you all how you can use a logic node. So if you let me just show you all that task just for a recollection. So you can see this is a logic node, and within the logic node, if you come to the connections property of the logic node, you can define if else if conditions. You can add else if, multiple level of else if, and the final else will be executed when none of the above ifs are satisfied. You can also go in for and conditions, you can go in for or conditions. But one of the disadvantages in this case is, you can put a entity over here, or, response of a service call over here. That is one, that is okay. Then you can select the operator. But in the third text box, you have to put a definite value. Okay, so it cannot be, if you're comparing two entities, you cannot put over here another entity. Okay, so it has to be a definite value. It can be a string, it can be a number, it can be a date, whatever, but it has to be a definite value. Many a time we come across situations where we have to compare between two entities, okay, or we have to compare between the responses, the components of a responses of an API call. So in those cases, using the logic node will not work, okay, because this place you cannot put context.entities.name of the entity. The logic node is not going to work in that case. So those kind of business logics you have to implement through a script node. So how do you implement business logics through a script node? Coming back over here, I have added a script node, and let's go back. Okay. So this is the script. It is a simple JavaScript. Okay, so you can see I have checked over here if the account type is equal to savings and the balance is greater than equal to 1,000. Then we will continue with the flow and add the row into the table. Similarly, if the account type is checking and the balance is greater than equal to 500, we are going to add the row into the table. And otherwise, if none of these above ifs are satisfied, that means the user has not provided the balance correctly as per the type of account he has selected. So we will come up with an error message. Now, we all know that we can define this alternate flows. Okay, one is when the service call will be made and the row will be added into the table, and the other is where an error message will be displayed. So these alternate flows can be defined from the connections property of a particular node. Okay, you can do it from a logic node when you have multiple if else's, or you can do it from a connections property of a particular node. So this alternate flows are to be defined from outside the script. Okay, where you are writing the script, you cannot say over here, okay, if this is true, if these conditions are true, then go to the service node. Okay, otherwise go to the error message node. You cannot define it within the script. You have to do those transitions from the connections property. So you need some value, you need some variable or status which is accessible outside the script, using which you are going to define the alternate flows. Now I have used a variable over here, next node. This is just a variable. I have named it as next node. Okay, so I have used a variable over here called next node, and I have assigned it the Boolean value of true or false. So what I'm going to do is, in the transition property, I'm going to see if this particular variable is true. Then I go ahead with my API call, and if it is false, I go ahead with the error message. But the disadvantage is I could have defined this variable as var followed by the name of the variable. That is the way you define variables in JavaScript. But the disadvantage of this variable is that the scope of this variable is limited to the script only. So once the script comes to an end, this variable is no longer available. Okay, so the scope of it, the life of this variable is restricted to this particular script only. So I'm going to use this variable outside the script because I'm going to use it in the transition properties or the connections properties. Okay, so defining the variable in this way is not going to work. I need a variable. You can think of it a variable which is more global in scope so that it is accessible outside the script where it is defined. So here what you can do is you can add the variable or define the variable within the context. Context, like I have said yesterday, is the object that holds all the information that is required in order to continue with this particular task. So as long as the task is in execution, whatever information you have saved in the context is available. So what I'm doing here is I'm creating a variable. The name of the variable can be anything, but I add the variable within the context. So the way to do it is context dot the name of the variable. The advantage of defining a variable in this way is if you come out of the script, you will see I have used this variable in the connections property, which is outside the script. Okay, so here I have said that if context.nextNode is equal to true, then I go to the service call, else I go to the error message. Okay, so it's very important to understand writing a JavaScript. If you have knowledge of scripting, any coding knowledge, you can just refer to JavaScripting and how to implement a logic. It is very simple to use, but at times we will need variables like this which we want to use outside the script. So in those cases, remember to define the variable or add the variable within the context. Any other way, if you are defining the variable, the scope of the variable is limited to the script only. Any questions on this? Okay, so once we have done that script, let me just quickly show you all the service call. This was the API that we are using. Okay, this is not the API.
Hey, Jayanti, quick question.
Yeah.
Hello.
Yeah. Please go ahead.
Yeah, so you just, that's an amazing feature you showed about the whole JavaScript through which you're controlling it. But one question I have, is there a provision to include any external JavaScripting which is already available as an include clause and take it from there, or everything has to be copy pasted here?
No. So if you are, it's like you build a library or you define some functions and you want to use those functions, right?
Yes.
You're asking about that.
Yes.
Okay. Yeah. So you can create an external file, okay, a JavaScript file where we usually use those kind of files, to define some functions and all, which we might use across multiple bots. So you can create files like that and you can upload that file. Okay, so we have something called, we call them the script files and all. We can upload that file, we can attach that file to this particular bot, and once the file is attached to this bot, we can use all those functions which are defined in those files in the JavaScripts that we are writing. That is possible.
Okay, great. No, thank you.
Okay, so coming back to the service call, actually my API was incorrect. Okay, so that is why. So this is the API that I was using yesterday, but what I want to show you all is a post call, how you go about with a post call. It can be any API, but when you have a post call, actually the post call should have a body. Okay, so that is the parameters that you would like to post into the table that you're accessing through this particular API. So here, once you have a post call, remember that you have to define the body of the post call. So the type of the body can be JSON. I prefer JSON. I find it easier to use. But you can go in for a form, way of posting the body where you will get two columns coming up. On the left-hand side should be the name of the column in the table. On the right-hand side should be the value that you want to add to that column. Okay, so if you look into this particular second. So you can see these are the names of the columns. Okay, so that is what I have done right now. Okay, so you can see over here the names of the columns. Okay, remember this name has to match with the way the column has been named in the table. On the right hand side, I have the entity that I would like to post for this particular column. If this value is coming from a form, digital form that you have designed, in that case, it should be context.forms.name of the form dot the name of the component of the form. Okay, and be very careful with form name and the component name. Most of the time, I see participants facing an issue that it is not working because maybe the form name is not correct or the component name is not correct. Okay, it's case sensitive, so be careful when you are using form elements in anywhere in your dialog task. Okay, so this is something that you need to understand with the post call, that you need to define a body, and the body is actually the data that you want to post using this API. So your left hand side should have the name of the column in the table, the right hand side should have the value that you would like to add into the table. Okay, any questions on this? Okay, so that was the first task that I have created here. I have an alternate flow which is just displaying an error message. You can ask the user that do you want to re-enter the balance, and then after removing the instance of this particular balance entity, you can connect back over here. Okay, so those flows I guess right now is clear to you all because we have discussed it in yesterday's session. There is another task. This is a very simple task. Okay, so I have created this for NLP training purpose actually. So there are two entities, account ID and payment amount. Account ID, I have reused the entity. Now we support component reusability on our platform. So, you know, if you have defined some entity or maybe some service call or maybe some, you know, messages, and the same message or entity or the service call, any component that you have defined anywhere, any node that you have defined in any of the dialog task, if it is the same node is to be used in some other dialog task, you don't need to recreate that. Okay, you can, what you can do is when you click over here to extend your conversation, you select any type of node from here, let's say a message node. Not only do you get the option to create a new node, you get the list of all the nodes that has been already created. So if you want to reuse any one of them, you just click over here and you reuse that particular node. It creates a new instance of that particular node. So you don't have to rebuild all the nodes again and again. If it is the same node with the same definition across multiple tasks, you can create it once and reuse it across all the dialog tasks. For an entity node, we have a very special feature also. When you are reusing the node, this is the same account ID entity. Now, when I had created this entity for the check balance task yesterday, I had provided multiple prompts. Okay, so you can see all those prompts coming up over here. But let's say when you create a new instance of a particular entity, you want this prompt to change. Okay, the rest of the definition of the entity remains the same. You cannot change the type and all. Okay, that has to be same across all the instances of the entity. Because if I change the type over here, it will affect all the instances of the entity across all the tasks. But I can change the prompts across the instances. So for a given instance of an entity, let's say I don't want these prompts, I want some other prompt to come up. Okay, so what you can do is click on this particular settings wheel and say override for this instance, enable that. Okay, and here I provide a prompt like enter the account number to transfer funds from. Okay, so here for this entity, I'm not using the default prompts that were given, but I have provided a particular prompt which will be used only for this instance of this particular entity. I can add multiple prompts over here that works. Any one of these prompts will be picked up only for this instance of the entity. For the other, for the check balance task, you will get to see those default prompts coming up. If you have reused this account ID entity in some other task, those default prompts will come up. Only for this instance, you will get to see this particular prompt coming up. Okay, any questions on this? And finally, we have another entity over here, payment amount, and a message that the request will be processed within 4 working hours. So these are the 2 tasks that I have added, and I'm going to use these tasks for the NLP training. So let's get started with the main topic of today's session, that is the NLP. And like I have said yesterday, NLP is the intelligence of the bot, the natural language processing. And it is that particular component of a chatbot that enables a chatbot to simulate a human being as a conversation partner. So when I say that a chatbot allows the user to talk, to converse with the bot using the free-flowing language, the first thing that comes up to our mind is the chatbot should have the intelligence to understand all the possible utterances coming from the user when the user wants to perform a task. Okay, so we have to build this intelligence within the NLP. The NLP is there. It has all the features, but you have to utilize it. You have to build this particular intelligence for the bot that you have built. Now, how do we do that? Yesterday, we have seen that when it comes to dialogue task, if we are using the name of the task, it is the NLP engine which is qualifying the task. Okay, so today if I say check balance, the NLP engine has the intelligence to understand that since the words which are used in the task name are present in the utterance of the user, this is the task the user wants to perform and the task gets initiated. Now, you do not have to use the words one after the other or only the words exactly the way the task has been named. I can also say, I need to check my account balance, or can you help me check my balance? So as long as the 2 words which are used in the task name are present in the utterance of the user, NLP engine can qualify the dialogue task correctly. Okay, but what about the situation where the user says something like this, how much money do I have? Now, once again, this is an utterance which should actually qualify the check balance task, because if the user is asking a banking bot, how much money do I have? Of course, he's asking about the balance in his account. But here he has asked the question in a way where he is not using the words which are used in the task name. So these words are known as label words. Okay, the words which are used in the task name are known as label words. So the label words are not present in the utterance of the user. So we have not trained NLP as of now to understand that this particular utterance of the user should qualify the task check balance. So this is the intelligence. The default is that if the label words are present, and NLP can qualify a task. That is the default intelligence of any chatbot built on our platform. Additional intelligence the user needs to provide to the NLP. So like I yesterday said, our NLP is actually a combination of 3 separate engines. That is the machine learning engine, the fundamental meaning engine, and the ontology-driven knowledge graph engine. Out of these, the machine learning engine and the fundamental meaning engine can be trained to qualify dialogue tasks. So you have multiple dialogue tasks. Which engine are you going to train to qualify the dialogue tasks? It is the machine learning engine and the fundamental meaning engine. Machine learning engine will be trained with training utterances. What are training utterances? Possible statements or utterances that can come from users when they want to perform a task. So you need to build a corpus of all of those. You need to list out all of those utterances. And once you have a list ready, you can train the ML engine with all those possible utterances. The other engine, FM engine or the fundamental meaning engine, can be trained with patterns. Okay, so we can build patterns using operators which are supported by our platform, and a single pattern can be built in a way that it can handle multiple utterances coming from the user. Why do we have two engines for doing this work? Because there are certain situations where the ML engine will work better than the FM engine, or certain situations where we should not train the ML engine to handle the utterances. Rather, we will train the fundamental meaning engine to qualify the dialogue tasks. Okay, we'll look into all of these things. And finally, we have the ontology-driven knowledge graph engine, which can be trained to qualify FAQs. How do we train the knowledge graph engine? We train the knowledge graph engine by building a hierarchical structure of key terms that we will identify from the questions, which is known as the ontology. And once we build the ontology, we can train it further with synonyms of those terms, with term usage, with tags, with alternate questions, with patterns, and so on. So we will see all of these different ways of training the NLP engine. Now, how do these three engines work together? When an utterance comes from the user, all these three engines get into work. Okay, so there's no order like first the ML will work, then the FM will work, nothing like that. All the three engines will work together, and using the training that has been provided to them, they will try to qualify intents either as definite match or as possible match. Okay, so and if there is no similarity between the training and the utterance coming up from the user for a given intent, then the intent gets disqualified. So definite match means when a particular NLP engine is very sure, is confident that this is the task user wants to perform, because the utterance of the user has matched exactly with the training that has been provided to the engine to qualify that particular task. Possible matches when it does not match exactly with the training, but the similarity is high that it is considered as a possibility by the particular NLP engine. So the outcome of intent identification by each of these engines can be either a definite match or a possible match. There can be situations, there will be situations where some of the intents will be disqualified because there's no similarity between the training that has been provided to qualify that intent and the utterance coming from the user. Now, after the intent identification takes place, maybe one of these engines qualify a particular intent as a definitive match, or multiple intents can get qualified as definitive match, or a single intent can get qualified as a possible match, or multiple intents get qualified as a possible match. Then who decides which one is the winning intent? We have a fourth engine called the ranking and the resolver engine, which declares the winning intent. So all the intents identified by each of these engines, that is the FM engine, ML engine, and KG engine, is finally sent to the ranking and the resolver engine, which declares the winning intent. If the ranking and the resolver engine sees a particular task has been qualified as a definitive match, then it declares that as a winning intent and the task gets executed. If multiple tasks get qualified as a definitive match, then the choice is presented to the user, and the user is asked to select the task he wants to continue with. If a single possible match, then that task gets qualified by the ranking and the resolver engine, and the execution of that task begins. When there are multiple possible matches, ranking and the resolver engine will rescore all those possible matches and pick up the one with the highest score as the winning intent. So these are the different ways in which all the four engines work together. And now we will see how we train them. And finally, we will see how the ranking and the resolver engine is declaring the winning intent. Okay, so I have said a lot of things. Maybe it is not clear to you all right now, but let's start off with the training. I guess whatever I spoke about, you will get clarity on that. Okay. So let's start off with the natural language section, training section. And the first training that we will provide is to the machine learning engine by adding utterances. What are utterances? You can see over here, I have a file where I have listed a few utterances for each of these tasks. Okay, these are training utterances. That means these are possible utterances that can come from the users when they want to perform a particular task. Okay, so like for the check balance task, I have a few utterances. For the open account task, I have a few utterances. In this way, you should have utterances for all the tasks that you have built within your bot. Okay, build a corpus of that, build a list of all possible utterances. And once you have the list ready, come here, come to the particular task, click on utterance here, and start adding your utterances. Okay, so one of the utterances that I was trying right now is how much money. Okay, once you type in your utterance, press enter to add that particular utterance. Okay, so in the same way, if you have a list ready, okay, either you can import that list. I'll show you all how to import it. But right now what I'm going to do is I'm going to copy it from here and put it here. Now, when you are adding utterances, there are a few things that you should remember. That is, now see, the user is not only going to say balance remaining or enough money. The user is going to say something like, do I have enough money in my account? Okay, or does my account have sufficient funds? Or how much money do I have? Now, I have only picked up the important words, okay, from the utterance, from the possible utterance. I have picked up the important words and I'm adding those words as the training utterances for the machine learning engine. All of y'all should be doing this, okay? So don't add your utterances blindly. Look into an utterance, see what are the important words over there. Those words like do I have, can you please help me, okay? How can I? So these are not important words which will tell the NLP engine what task to perform. Pick up those important words, those key words that you see in the utterance, which actually tells you what is the task to be performed, and add those words as the training utterance. Okay, so this is very important to remember that your training utterance should contain the key words that you see. Okay, do not just blindly keep adding the utterances because that can lead the ML engine to incorrectly qualify a task. We'll come to that, why it will incorrectly qualify when we see how it is working. Now, once you add utterances for a particular task, okay, you can just close this, okay, and then go to the other task for which you want to add the utterances. Let's say the open account task, okay, and once again start adding your utterances here. Let me just quickly add a few utterances. It's very easy to train the ML engine, but ML engine works very well. If trained properly, it will qualify intents correctly. Okay. Now, once you have added all your utterances and all over here, okay, the next is you have to train the ML engine to build the model internally, which it will be using to qualify intent. So whenever you are adding utterances, you're making changes in the existing utterances, maybe you are removing some utterances because ML is incorrectly qualifying a task using that utterance, what you need to do is remember to train the ML engine. So click on the train button, which will start the training of the ML engine. It takes a little time to train the ML engine because internally it will build the model which it will be using in order to qualify tasks. And the way the ML engine will work after it has been trained is that when an utterance comes from the user, it will look for the similarity between the training utterances and the utterance coming from the user. So it will look for the presence of these words that you have added in the utterance of the user. And depending on the number of words found, it is going to qualify a task either as a definitive match or as a possible match. If it does not find enough words matching with the training utterance and the utterance of the user, it will disqualify that task. Okay, so let's see how it is working. The training is done. So let's go back here. And last time, my utterance, how much money do I have, led to a failure in intent identification where the bot came back with a standard response where it displayed all the tasks it can perform. But let's retry that same utterance. So I'm retrying the utterance, but this time you can see the check balance task has been qualified. And if you come to the ML analysis section, you will see there is a section for the machine learning, that is the ML. And you can see machine learning has qualified the check balance task as a definitive match, because machine learning is sure this is the task the user wants to perform because of the similarity score. Now, how did it get this similarity score? Because there is an utterance which matches with the utterance coming from the user. So all the words in the training utterance of that particular task is present in the utterance coming from the user. So machine learning is confident that this is the task the user wants to perform, and it qualifies that task as the definitive match. But this is not the winning intent as of now. Okay, so who declares the winning intent? If you come down, you can see the final resolver, which is the ranking and the resolver engine. And if you scroll down here, you will see the ranking and the resolver engine has declared the check balance task as the winning intent. So basically the ranking and the resolver engine, if it sees one of the intent identification engines has qualified a task as a definitive match, it declares the task as the winning intent. Okay, but does this mean that ML engine will only qualify tasks if all those tokens, all those words in the training utterance are present in the utterance of the user? No. Okay, it will work with similarity. If all the tokens are present, it is definite match. Okay, but if I say something like this, okay, so if I say, something, let me just try this. Okay. Okay, so once again, you can see the check balance task has been qualified, and I have said, do I have money? Okay, so I have not added any utterance like this, but if you come over here, you can see the scoring has gone down. Okay, because this time the utterance has not matched exactly, but a few words from the training utterance are present in the utterance of the user. So the scoring has gone down, but it has not gone down to a level that the task can be eliminated or discarded. Okay, it does not mean that ML engine all the words has to be found. It works with similarity. It is a probabilistic engine, so it will look for the presence of those tokens that you have mentioned in the training utterances. Tokens are the words. Okay, so tokens in the training utterance, and if those tokens are found in the utterance of the user, depending on the number of tokens found, it's going to qualify a task either as a definitive match or as a possible match. Okay, and the order of the words is also not important. Okay, as long as those tokens are found anywhere in the utterance of the user, machine learning engine can qualify a task. Okay, is it clear to you all how it is working? Now, one thing over here, I'm saying that it is a definitive match, it is a possible match. So how does machine learning actually understand when to, qualify a task as a definitive match, when to qualify a task as a possible match? Okay, it will score it on the similarity. But if you come to the thresholds and configuration, where you have the section for machine learning, okay, so you have a section for machine learning over here. If you click on this configure button, you will see the thresholds are mentioned over here. So if the similarity is 95% above, it is taken as a definitive match. 80 to 95% is a possible match with a high confidence. Okay, so though it is not a definitive match, still it is a possible match with a very high confidence if the similarity score is between 80 to 95%. If the similarity is below 30%, okay, then that task gets eliminated. So at least the similarity has to be above 30% to be considered. Okay, 30 to 80% is possible match with a low confidence score. 80% above is very high confidence score. 95% above is a definitive match. Okay, so this is where we specify the thresholds. These are the default values. We have seen these default values have been given after testing a lot of bots, and we see that these thresholds work well. But if you want to change it, if you want to consider more intense by the machine learning, then you can decrease this over here. Okay, so more intense will get qualified. If you want definitive matches to be more, so instead of 95% above to be considered as a definitive match, you can reduce this over here. At least 80%. Below 80%, you cannot go in for definitive match. Okay, so you can bring it down till 80%. So if the similarity is 80% and above, then it will be considered as a definitive match. Anytime after making these changes, these directly affect the scoring of the particular engine. If you are not happy with the changes, you can click on the reset button to get back these default settings. Okay. Any questions on these thresholds? Okay. Now coming back to the utterances, so you can see that machine learning works with the similarity. Okay, so depending on number of words it finds similar with the training utterance coming from the user, it will give a score, and if the score falls within the different thresholds, it will either qualify the task as a definite match or as a possible match. Now there are times when our utterances can contain possible entity values, okay, like this particular utterance for the open account task. So if I put this utterance over here, you can see keep $1,000 in new account. Now, if you just now before this, we were discussing the open account task. We have a particular entity called balance. Now, this balance entity is going to hold the opening balance of the user, which will be a numeric value. Now, this 1,000 that is mentioned by the user in the utterance is actually a value for that particular balance entity. Our NLP has the capability of extracting entity values from the utterance. So if the utterance of the user contains entity values, you will see when that particular entity comes into the context, NLP will extract the value and it will not prompt the user again for the entity value. Okay, how it does that, we'll discuss in today's training, but a little later on. Okay, but it has the capability to extract entity values from the utterance of the user if the user has specified it. So here, this value of 1,000 is actually a value for the balance entity. Now, if I'm adding this utterance and if the user says that I want to keep $1,000 in a new account, it works fine. Okay, so you will see it is a definitive match. But if the user says, I want to keep $500 in a bank account, something like that, you will see the scoring coming down. Why? Because the 1,000 is not matching with the value present in the utterance. But the user, you cannot specify it, like, right? The user will always say $1,000. The user can say $500. The user can say $2,000. The user can say $5,000. When the user is mentioning the opening balance in his utterance, he can provide any numeric value over there. We cannot fix that numeric value to 1,000. But when I'm adding an utterance for the ML engine to qualify the open account task, and within that utterance there is a possible entity value, we need to tell the ML engine that to not use the value in this position for scoring this intent, because this is a value to be used for an entity and the value can be different in the utterances of the user. How do you do that? Once you add that particular utterance over here, double click on this value. Immediately you will see our platform will come back, or the bot will come back with the list of entities configured for this task. So you can see the 3 entities over here. Select the entity with which you want to tag this value. So I want to tag the value of 1,000 with the entity balance. The advantage of doing that is, now if the utterance of the user matches with this particular training utterance, ML will know that this position can contain any value other than 1,000 because it has been mapped or it has been tagged with the entity balance. So it will not use the value present in this position for scoring this particular intent. This approach is known as NER tagging, or named entity recognition tagging. It helps in the scoring of the ML engine. So if your training utterances for the ML engine contains possible entity values, make sure that you tag those entity values with the respective entities. It will help ML in the scoring, because ML will not use the value present in this position in the utterance of the user for the similarity score of this particular task. Okay, so this is a very good approach. Without it also it will work, but it's always good that if you have possible entity values, tag it with the respective entities. Okay, so if you have this thing like this, okay, so something like this coming from the user. Once again, this particular utterance has two entity values. Okay, this is the name of the person, this is the type of account. So what you can do is, once you have added that utterance, double click, select the entity with which you want to tag it. Once again, double click on this. Okay, select the entity with which you want to tag it. So you can do multiple these things. Your entity values can be present within in different positions in the utterance of the user. So add utterances with the entities in different positions and tag it with the respective entity, so that if this entity values are present in the utterance of the user, ML will know that these are entity values and these should not be used for scoring the particular intent. Okay, any questions on this? And once you have done that, remember to click on the train button to trigger the training of the NLP engine. You can also define all your utterances that you would like to add for tasks within a CSV file or a JSON file, where the first column should be the name of the task and the second column should be the utterance with which you would like to add to that task. So once you have a CSV file like that, all you need to do is when you come to this section, click over here in this three ellipses and see import utterances. Select the file which contains the utterance, but remember you have to put the name of the task for which you are adding that utterance also, and the name of the task should match exactly with the names that you have provided here. Okay, so this import method will add all those utterances to the tasks for which it has been defined. And once you import it, just click on the train button to trigger the training of the ML engine. If you would like to export utterances from here, that is maybe you have a similar bot with similar types of tasks, you have trained this bot with utterances, you want to export these utterances to be added to that bot, then you can go in for export utterances, export it in any one of these formats and import it within your destination bot. Okay, so that is the import and the export of utterances. Any questions on that? Okay, certain things to remember. ML learns by experience. So the more you train, the better is the intent identification for the ML engine. So if you have dialogue tasks like this, you should provide at least utterances in hundreds. Okay, so 5 or 10 utterances are not good enough to train the ML engine. Though I have done that over here, but that is I'm just showing you all how to do it. But if you are going in for live implementations, in that case, your training utterances should be in hundreds, better in thousands. Okay, that is one thing. The second thing is provide a very balanced training. That is, all the tasks configured within the bot should be trained with similar number of utterances. Okay, the reason behind it is, as you see, that ML just works with the similarity. So today, if you train one task with 100 utterances and another task with 5 utterances, there will always be a possibility that ML will find similar words or similar tokens in the task, which has been trained with higher number of utterances. So the possibility of that task getting qualified increases significantly. So always provide a balanced training. And if you have words which are common across multiple tasks, okay, something like this, let's say, for the open account task, I have an utterance like open or let's say new account. Okay. For the check balance task, I have an utterance like how much money do I have in my account? Okay. So money in account. For the make payment task, I would request all of you all to be on mute, please. Okay. For the make payment task, we can have another utterance like, or let's say, pay from my account. Okay. Now the word account is common across all of these utterances. Okay. But each of these utterances are for different tasks. When you have common words like this, make sure you add utterances for each of the tasks which are using the common words. Okay, that is very important. Okay, so provide a very balanced training. Common words which can be used across tasks. Make sure that you have utterances for each of these tasks which are using those common words. Okay, so these are certain things that you should remember when you are training the ML engine. But this is the first engine that you should be training when you are talking about NLP training. So build up corpus of all possible utterances and add those utterances as ML training utterances for the tasks that you have defined for your bot. Any questions on this? Now coming to the other engine, that is the fundamental meaning engine. Let us consider a situation like this. Let's say the check balance task. Okay, so I have a task called check balance. Now the user can say, show my balance. Can you show my balance, or just show my balance, something like that. Okay, or fetch balance. Okay, can you please fetch the balance in my account, or fetch my balance, or can you help me fetch the balance in my account, something like that. So the words, important words there is fetch and balance. Okay, the user can say, I need to see my balance. The user can say, get my balance. Okay, or retrieve my balance. Now, what is the disadvantage? I can add these all as ML utterances. Okay, quickly, I can just click on utterances here and type in each of these utterances, press enter, and train the ML engine. The disadvantage in this case is the word balance is repeated again and again. Okay, so you will come across utterances like this where most of the utterances are the same. A single word or two words here and there changes. Okay, so very similar utterances with very little changes in some of the words in those training utterances. It is not a good approach to add these kind of utterances for the ML engine, because if the ML engine sees multiple utterances which are repeating the same words again and again, ML engine will learn this word in the utterance is very important to qualify the check balance task. So whenever an utterance comes from the user, if it finds the word balance in the user's utterance, ML will have all the possibility to qualify the check balance task, because the word balance has been repeated again and again across multiple training utterances, and ML by default has learned the word balance is very important to qualify the check balance task. So now if the user says by mistake says something like this, pay from my account balance, you will see the presence of the word balance will lead the ML engine to qualify the check balance task. Whereas this is actually for transfer money. Okay, so that is a make payment task. Okay, because the user wants to pay some money over here. So just because the word balance is very important for the ML engine to qualify check balance task, it finds the word balance in the utterance of the user, it will go and qualify the check balance task. So these kind of utterances, which are very similar, you should not train ML engine with this. Then how do we handle these kind of utterances? Because these are all valid utterances coming from the user. In this situation, we train the fundamental meaning engine or the FM engine with patterns. So let's start discussing how we can define patterns and discuss the different situations where we should go in for training the fundamental meaning engine and not the machine learning engine. Okay, so to build patterns, we come to the task and we click on patterns over here. Okay, now when you are building patterns, you can use multiple operators which are supported by our platform. So the first operator that I'll be using when I'm building the pattern is the operator which will allow me to provide a variation in the first word, that is either check or show or fetch or see or get or retrieve. How do I do that? I open the square brackets over here and I put the variations. That is a list of synonymous words. Those are actually synonymous words, right? So either check or show or fetch or see or get or display or retrieve. Okay. This means any one of these words can be present in the utterance of the user, followed by the word balance. Okay, or I can say either followed by the word balance. I can make it a little more flexible. I can say either the word balance or the word money or the word cash. So this particular pattern means the utterance of the user can have any one of the words from the first list of words, any one of the words from the second list of words. So now see the number of utterances that you are handling through a single pattern. The user can say check my balance or check my money or check cash in my account. The user can say show balance or show money or show cash. Similarly with fetch, all the combinations, with see, all the combination. So multiple utterance, huge number of utterances you are handling through a single pattern that you have created using one of the operators supported on our platform. But there are certain other inherent things that this pattern means. This pattern means any number of words before the pattern starts, any number of words after the pattern ends, okay, and maximum 3 words between the words mentioned in the pattern. Okay, so can I see the money in my account? Can you show me the cash available in my account? Can I, or fetch balance, just fetch balance all by itself, or fetch the available balance in my account? All of these can be handled by this single pattern. Okay, as long as these words are found, one of these words are found with maximum 3 words in between, this pattern is going to work. But there's another thing also very important. That means the order of the words is very important over here. So these words have to come exactly in the order in which they have been mentioned. So one of the words from the first list must come before one of the words from the second list. Okay. So once you define a pattern like this, let's go back and see how the fundamental meaning engine is using the pattern to qualify a task. Okay, so can you show the available cash in my account? Let's see which intent is getting qualified here. So you can see the check balance task is getting qualified, and nowhere in this utterance do you find the words check and balance present. So the NLP has been trained to qualify this task. Let's see which NLP engine is doing the qualification. So if you look over here, ML has qualified open account task as a possible match. You can see the similarity score because there are a few utterances which we have added for the ML engine where the word account has been used. Okay, so if you look into the training utterances that I had added, you can see the word in is repeated. Okay, and here I have the word in. Okay, then you can see the word account is repeated. Okay, and the word account is present in the utterance of the user. So that has led the ML engine to qualify the open account task. Okay, Whereas if you come down, the fundamental meaning engine or the FM engine has qualified the check balance task as a definitive match. Let's go down and see the task has got qualified using a pattern. Which pattern? This is the pattern that we have defined right now. So you can see one of the words from the first list of words is present in the utterance. One of the words from the second list of words is present in the utterance. Maximum 3 words. So right now I have 2 words, so the pattern works and the task gets qualified as a definitive match. So which one is the winning intent? We have one task qualified as a possible match by the ML engine, one task qualified as a definitive match by the FM engine. So if you come down over here, you will see it is finally the ranking and the resolver engine, which is declaring the winning intent. And you can see the winning intent is the one that got qualified as a definitive match by the fundamental meaning engine. So that is the first pattern which you see in working, which will give you a variation in the first list of words and the second list of words. Is it clear to you all how this pattern is working? Any questions on that? Okay, now let me just make a change. Okay, the user says, I have cash, show it. Okay, so I've just changed the order of the words. Last time, whatever was the utterance, the rest of the words does not matter. The word show was before the word cash. It matches with the way the words has been defined in the pattern, the order of the words in the pattern. This time I've just reversed it. The word cash is coming before the word show. Okay, and you can see intent identification has failed. Okay, because the order of the words in the pattern is very important. Okay, now how do I make a change in this pattern so that the FM engine does not consider the order of the words which are mentioned in the pattern? So now I'm going to use the second operator over here, which is the unordered list of words, which is the double angular braces. Okay, so here you can see I have added the double angular braces, which means that FM engine will look for the presence of one of these words, maximum 3 words between the words, but the order of the words is not important. Okay, so once I have made the change here, let's go back and talk to the FM engine and let's retry that utterance which has failed. Okay, so you can use any of it. Okay, it's not that you have to use show it only. You can also say need to see it. Okay, something like that, one of the words. Okay, so you can see the check balance task has qualified, though the order of the words have changed, but the pattern works. Okay, once again, you can see ML engine has qualified check balance task as a possible match because of the similarity between the training utterances and the utterance coming from the user. But check balance has also got qualified as a definitive match by the FM engine using this pattern. And how did this pattern work? Because these words are enclosed within the unordered list of words operator. Okay, so that is the second operator that you can use when you are defining patterns. Okay, but these words are mandatory. Okay, so one of the words from first list of words, one of the words from second list of words has to be present in the utterance of the user. It's not an or condition where I can just say, money, or the user just says show, or the user just says fetch. This pattern will work. No, it is not going to work. These words are mandatory. One of the words from the first list, one of the words from the second list. Any questions on this pattern? I'm going to add a few more patterns where I'm going to discuss the other operators. But is this pattern clear to you all? Okay. Let me just go and add a few patterns for the make payment task, or I come to the patterns for make payment. I have a list of patterns ready, so I'm just going to copy from there and put it. Okay. Now, if this is the pattern to qualify the make payment task, okay, so here if I say, let's say, So you can see the make payment task has qualified. And if you come back over here, it's very good to understand the NL analysis, because as a developer, you will need to refer here to see which, engine is actually qualifying the task. So you can see ML has eliminated both of the tasks because the similarity score is very low. It's below 30%, so it does not consider both the tasks. But FM engine has qualified the make payment task as a definitive match using this pattern. So the word transfer is there, the word cash is there, and the word account is there. Okay, but here if I just make a change in this utterance and I just say transfer cash, the user can always say that. Okay, that word account may or may not be present in the utterance. Okay, so if I just say transfer cash over here, you can see intent identification has failed. Why? Because this pattern has failed. Partial qualification of pattern is not allowed on our platform. Okay, so if I have defined a pattern like this, the word account is mandatory in the utterance of the user. Okay, since the word account is not present over here, the transfer word comes from the first list. Okay, the cash word comes from the second list, but the other word which is defined in the pattern is not present in the utterance of the user. So the pattern fails, and as a result, FM engine does not qualify this task. So how can you define optional words? You will come across these situations where certain words may or may not be present in the utterance of the user. So I want to make the word account optional. Okay, how do you do it? You enclose the optional word within the curly braces. Okay, so that makes a word optional. It means this pattern will work if the word account is present. This pattern will work even if the word account is not present. Okay, so we define optional words, typically required to define certain optional words between the other list of words that you are defining within a pattern. Okay, so let's go back here. Okay, and let's retry this particular utterance. And you can see make payment task has qualified because, and once again, if you come here, you will see the same pattern has been used to qualify the task. This time the pattern works because the word account is optional in the pattern and the word account is not present in the utterance of the user. So that is the third operator that we can use when we are defining patterns. That is the optional operator. Is it clear to you all? Any questions on this? Okay. What are the other situations where you should be using patterns? The other situation is to handle single word utterances. Now, so one was the first situation where you have repetitive words, very similar utterances coming from the user. So don't go in for training the ML engine. Try to build patterns to handle all those similar utterances. What is the second situation where you should be trying to build patterns? That is single word utterances. Now, what does single word utterances mean? Let's understand that first. Now, let's say if the user just says payment, okay, then the task to be qualified is the make payment task. Okay, the user just says payment, or the user just says pay, or the user just says transfer, nothing other than that. The bot should have the intelligence to understand the user wants to perform the make payment task. We have to consider, I'm repeating these words again and again, we have to consider the possibilities. Okay, so as an NLP trainer, you have to consider all the possibilities. Okay, so single word utterances is one of the situations that you should be considering. So user just says payment, the task to be qualified is make payment task. Okay, the user says something like this: is my last payment updated in my balance? Okay, the task to be qualified is check balance task. So when the word payment is coming in combination with the word updated, or let's say reflected, something like that, then the task to be qualified is a check balance task. But when the word payment is coming all by itself in the utterance of the user, then the task to be qualified is the make payment task. Okay, so I hope this use case is clear to you all. Is it clear to you all? Any questions on this? Okay. So what I'm trying to say is at times you will come across situations like this when a particular word present all by itself should qualify a task. But when that word comes in combination with some other words, it should go and qualify some other task. Here, if I go in for training the ML engine, it will be very difficult to make this, demarcation. Because if I add a single word utterance like this as an ML utterance for the make payment task, what happens is whenever the word payment is found anywhere in the utterance of the user, ML engine will qualify make payment as a definitive match because ML just looks for the presence of those words or tokens. And depending on the number of tokens it finds, it qualifies a task either as a definite match or as a possible match, or it disqualifies the task. Now, if you have an utterance which just contains one single word, it means if that word is found anywhere in the utterance of the user, it does not matter whether the word comes all by itself, it comes in a huge, in a very long utterance, but as long as that word is found anywhere in the utterance of the user, ML engine will qualify that task. So we cannot train the ML engine in a way that if the word is found all by itself, then go and qualify this. If the word is found along with some other words, then go and qualify some other task. Okay, so making this, demarcation is very difficult when you are only training the ML engine. This can be handled very easily using patterns. Now, how do we define patterns where I say if the word comes all by itself, then qualify a particular task. So I'm adding the second pattern for the make payment task where I enclose the word payment within the less than greater than sign. Now these less than greater than sign are actually anchors. Okay, so it anchors a word to a particular position in the utterance of the user. So the less than sign tells the FM engine to look for the word following this particular operator at the starting of the utterance of the user. So you can come across a lot of situations where you see that the utterance of the user has started with a particular word, and a task should get qualified because the user used that word right at the starting. It does not matter what he has said after it, but since the utterance of the user started with that word, we want to qualify a task. Okay, then you can use the less than sign followed by the word. Similarly, the greater than sign preceded by a word anchors the word to the end of the utterance of the user. So no matter what the user has said, if the utterance of the user ends with a particular word, then the task to be qualified is a specific task. So you can use the word followed by the greater than sign. So these are basically anchors. And when you enclose a word between both of them, it means the word all by itself. Nothing before it, nothing after it. The word all by itself in the utterance of the user. In the same way, I can say if the word pay or the word transfer comes all by itself in the utterance of the user. So I'm using two operators in combination, which you can always do when you are defining patterns. So the the internal operator, or this particular operator which is inside the anchors, says that any one of these words in the utterance, but I have used the anchors telling that only these words can be present. So any one of these words can be present in the utterance of the user. Then the task to be qualified is the make payment task. Now what I do is I go back to the check balance task over here, and I add a pattern where I say if the word payment is followed by the word update or reflect, then qualify the task check balance. So see the way I have defined the two patterns. One, I'm saying if the word payment is present all by itself, qualify make payment. But if the word payment is followed by any one of these words, then qualify the check balance task. Okay, let's see these patterns in working. And when you're training the ML engine or when you're building tasks, keep talking to the bot and see whatever training you are giving is giving you the expected output or not. Okay, just don't train and deploy the bot without testing it, because you might train thinking of something, but finally NLP can use its own logic to qualify the task. Okay, so the training you have provided may not work as expected. So always go in for testing along with training. One of the testing is talking to the bot. Okay, so you can see over here the word payment all by itself has qualified the make payment task. If you come to the NL analysis section, you can see FM has qualified the make payment task as a definitive match. If you come down, it has got qualified using a pattern, and the pattern is over here the word payment enclosed within the anchors. Okay, whereas I'm not continuing with the tasks because I'm just showing you all the intent identification. So I'm just, discarding the tasks again and again. This is a command available to the developers when they just want to see the intent identification, but they do not want to complete the entire task. Now, if I say, is my payment updated in my balance? Okay. So here you can see, if you come back here, you can see the check balance task has got qualified. And if you go back to the NL analysis section, once again, you can see the FM engine has qualified check balance task as a definitive match using the pattern, where the pattern says if the word payment is followed by update or reflect, then qualify the task check balance. Okay, is it clear to you all how we can use patterns to define single word utterances, and why should we use patterns? Is the use case clear to you all? Now, one point to note over here is that in the utterance, just give me a second, please. Okay, sorry about that. Let me just look into this question. Patterns qualify dialog tasks. Yes, patterns can be used also to qualify FAQs. I'll discuss that a little later when we are talking about the training of the FAQ engine. Okay, but patterns right now with the FM engine, remember patterns are only used by the FM engine, okay, when it is going in for qualifying dialog tasks, okay, not by the ML engine. Now here, if you just look into it, you can see in the pattern I have used the word in its basic form, that is update and reflect, but whereas in the utterance of the user the word comes up as updated or maybe reflected or something like that. It could, updating, reflecting, transferring. But when you are defining a pattern, you should define the word. You should use the word in the pattern as in the basic form, the verb in its basic form. Now, why is that so? Our FM engine will use the utterance of the user in its canonical version to do the pattern matching. What is the canonical version? It is the utterance of the user in its basic form. So if you look into the top part of this NL analysis section, you can see the original input of the user is this: is my payment updated in my balance? Okay, the first is a spell correction. So we have an inbuilt bot dictionary for each language. Common words, okay, the spellings, the correct spellings are given, and whenever an utterance comes from the user, it will try to correct it to its nearest word in the dictionary. So you can see the spell corrected input over here. If there is small little spelling mistakes, you will see the bot can handle that. Followed by the canonical version. So you can see in the canonical version, the word updated has been changed to update. So that is the, the utterance in its basic form. So when it is converting into the canonical version, all your verbs will be translated into its basic form. So if you say updating, reflecting, transferring, or updated, reflected, transferred, something like that, I'm using just these words as an example. You will see it derives the basic form. Okay. That is the lemmatized version. Okay, so it will remove that ing or ed and get the most meaningful basic word. You will see any numbers, if you have defined it in words like TWO, will be changed into the numeric 2. Any punctuations like question mark, exclamation, all of those will be removed, okay, in the canonical version. Anything in past tense will be changed into the present tense. All plurals will be changed into the singular form. And in this canonical version of the utterance of the user will be used by the FM engine to do the pattern matching. So when you are defining patterns, consider the words in its basic form. Okay, so that is why, though the utterance of the user has the word as updated or reflected, when I'm defining the pattern, I'm defining the pattern as update or reflect. Okay, so that is the difference between the two. At times, there can be a situation where you do not want to consider this lemmatized or this canonical version of the word. You want to consider the word as it is present in the utterance of the user. Maybe the lemmatized version or the canonical version of the word is something different. It's giving a different meaning. So you want to consider the word as it is present in the utterance of the user, and that word has been mentioned in the pattern. So how do you do that? When you are defining a pattern, if you want that particular word should be matched exactly the same way as it is mentioned in the original input of the user, then before the word, put the single apostrophe. Okay, now if I say over here updated, that means the word updated has to be present in the original input coming from the user. It will not match with the canonical version of this particular word, because the canonical version is update. You have not specified update over here. You want this word as it is in the original input to match with the pattern. Okay, so there use the operator single apostrophe followed by the word as it should be present in the original input of the user. Okay, so that is the next operator that you can use. Any questions on that? Okay. The other situation where you should be using patterns is to handle idiomatic sentences. Idiomatic sentences are sentences which clearly do not say what is the task the user wants to perform, but inherently it means a task. Because here, whatever patterns we are defining, if we look at it itself, we understand that this is the task the user wants to perform. But there can be utterances coming from the user where the user clearly does not say what he wants to do. Like here in this case, if the user says, am I a rich person? Now this statement nowhere says the user wants to check his account balance. Okay, but for a banking bot like this, if it has a task like check balance, that task can be initiated, because the amount of money he or she has in his bank is the amount, is how rich he or she is. So the presence of the word rich, so this is an idiomatic sentence. Okay, this does not clearly say which is the task, but it actually means a certain task. Okay, so if you come across idiomatic sentences like this, never go in for ML utterances, because once again, those words in some other utterance might lead some other task getting qualified. So always idiomatic sentences should be handled through patterns. So I can add a utterance like this over here. If the word rich is found anywhere in the utterance of the user, then qualify the check balance task. Or if the user asks, what is my monetary status, or what is my financial condition? Okay, so all of these statements, these kind of statements should lead to the task check balance. Okay, so Okay. Similarly, if the user says my father needs money, or my friend is in need of money or cash, all of these tasks should trigger the make payment task. So where you clearly do not, the user is not saying that he wants to perform a task, but inherently he means a particular task, always go in for patterns to handle that. Okay, so let's say friend or family. I don't need the word need because any three words between the two words. So if the user says my friend requires some urgent cash, that also should be handled through the pattern. Okay. So once you have defined these patterns, let's talk to the bot and see how it is working. So you can see the check balance task, and if you come here, FM Engine has qualified check balance task using the pattern which says if the word rich is found in the utterance of the user, then qualify the check balance task as a definitive match, and of course the ranking and the resolver engine declares the task as the winning intent. Okay, so that is the third situation where you should always consider patterns. Okay, any questions still here? The last thing before we go into the training of the KG engine is that you will come across situation where maybe you are using the same list of words again and again across multiple patterns. Something like if I say, check or show or fetch, okay, whatever, okay, followed by either dollars or let's say rupees or let's say euros, something like this currency symbols and all, then it should qualify the task check balance. Okay, whereas if the user says pay dollars or pay euros or transfer dollars, transfer rupees, transfer euros, it should go and qualify the task make payment. Okay, so the same list of words which are the names of the currencies are used across multiple patterns, across multiple tasks, or maybe in the same task. Okay, so either I can define this within the square brackets, I can define the list of words. Remember, no comma separated words in the list of items, you just put a space between the words. Okay, but what is a more efficient way of handling these kind of lists? Because maybe tomorrow you need to add a few more currency names to the list, or you want to remove a particular currency name from the list. So if these kind of dynamic lists you want to use within your pattern, and if there are multiple patterns where you have used the same list of words, any change in the list of words will lead to a lot of effort on the developer's side to make those changes, because you have to go to each of those patterns and make the changes. Okay, and when you have multiple patterns, right now I have just 3 or 4 patterns, but if you look into a real-time bot, you will see there are hundreds of patterns maybe. From there, identifying which patterns are using that list of words, making the changes accordingly there might become a very tedious work. So what is a more efficient way of handling these kind of lists of words which can be used across multiple patterns? And they might be dynamic, they might or may not be, but whatever, if it is a dynamic list and it can keep changing, what is a better way of handling that? We can create concepts which are collection of related words. Okay, so when you come to concepts over here, you can see some system defined concepts. These system defined concepts are used in our small talk section. So yesterday, remember, we had seen this emotion hello, and I said that this contains all those words like hi, hello, and things like that, and we had provided the bot response. You can see over here all those words defined within this particular concept, like good morning, good evening, hello there, hey, hello and welcome, hey there. So all of these possible utterances, which are actually different ways of greeting a person with the word hello, they have been put within this concept, and this concept is used in the small talk. Now here I want to define a concept which I'm going to use in a pattern to qualify a particular dialog task. How do you do it? Click on new concept, A concept name should always start off with the tilde sign. Remember that, okay? And type in the name of your concept over here. So let's say I name the concept as currency, and here in the synonym section, I put dollar, press and enter after each of these, okay? Rupees or euro. Once again, in its basic form, because I'm going to use in the pattern. So if the user says dollars, the canonical version of it will be that word in a singular form, that is dollar. Similarly, if the user says euros, the canonical version will be euro. So these are certain things you always need to keep in mind, okay? So I have mentioned these three words within this particular concept, okay? Once you have defined that, close it. So you can see the concept has been added. Let me just quickly create another concept. Let's say family members, okay? And I put words like, father, okay? Now, once you do that, so I've created two concepts over here, okay? And let's use these concepts. Now, once you define concepts, concepts can be only used within patterns, okay? So for intent identification or dialog task identification, you can use those concepts over here. So I come to the pattern, okay? And if the user says, I'm going to make a change in this existing pattern, so one of these words followed by either balance, cash, or money, or the words defined in the concept currency. Okay, so I just put tilde currency. So if the user says, show dollars or fetch rupees or show euros, something like that, those are the words which are defined within the concept currency. This pattern will be used to qualify the task check balance. Okay. Similarly, I come to the make payment task, and once again here, if the user says make, pay, or transfer followed by any one of these words or the words defined within the concept. Okay, so if the user says transfer dollars or transfer euros, that will be handled by this pattern. Similarly here, if the user says friend, family, or any one of those family members mentioned within the concept family members, okay, followed by needs or requires urgent cash, money, or fund. Now, once you have used the concept within the patterns, let's see how it is working. So make payment task getting qualified. If you come down over here, you can see ML has eliminated all, but FM has qualified make payment as a definitive match using this pattern. This pattern qualifies. The word account is optional, but the rest of the words are mandatory. So the word pay is present from the first list, and the word euros is present within the concept that we have used in the second list. Okay. In the same way, if I now say, fetch euros, so you can see the check balance task getting qualified, and you will see it has got qualified using the pattern where we have used that particular concept. Okay, so if you have the same list of words, a very efficient way is to define concepts. And the advantage is today, if you need to add a few more words over here, all you need to do is come to concept, click on edit concept, and if you want to remove something, click on the delete button. If you want to add new things, let's say, okay, you can add new words into the concept. So wherever you have added the words, okay, wherever this concept is used, the new word will also be considered. So that's a very efficient way of handling list of words which can be used across multiple patterns. Is it clear to you all? Any questions on this? Okay. So these are the different ways in which we can train the NLP engine to qualify dialogue tasks. Again, I'm repeating dialogue tasks, ML or FM, First approach is ML. It's more easier, it is more flexible, it is not rule based. So if the words are found, any order of the words, if certain words from the training utterance is found, depending on the threshold, tasks can get qualified. FM engine is more rule based because a lot of rules, okay, when you are defining patterns, it is actually rules that you are saying that these words has to be present in the utterance of the user. The order of the words is important unless and until you are using that particular operator, okay, or so you are defining rules using the patterns. Actually you are defining rules, and if those rules are satisfied by the utterance of the user, FM engine can qualify tasks. Yesterday we have seen that without any training also, the NLP engine qualifies tasks if the label words are present, and that is also done by the FM engine. So if I say submit details, or let's say submit account details, okay, so you can see the task getting qualified, that is submit details. I have not trained the NLP to do this. If you come to the NL analysis section, once again you will see it is the FM engine which has qualified submit details task. How did it qualify this task? Using the word match algorithm. The word match algorithm, if you come here, you can see the word match algorithm. It is actually the word match algorithm is the FM engine looks for the presence of the label words, which are the words used in the task name, in the utterance of the user. You can see in the word section, you can see the first word in the utterance of the user has matched with the label word submit. The third word in the utterance of the user has matched with the label word details. Okay, there is a section called detailed section where you can see the first input word is submit in the utterance, which has matched with the label word submit. The second matching is the third input word, which is details, matched with the label word details. So using the word match algorithm, FM engine has qualified the task. So without any training, it is the FM engine that looks for the presence of the label words in the utterance of the user and qualifies the task if those words are found anywhere in the user's utterance. Okay, is it clear to you all? Any questions on that? Okay. Now coming to how we train the KG engine. Now before we go in for training the KG engine, let us quickly understand first how the KG engine works. Now when you look into the FAQs, let's say an utterance coming from the user, and by now I guess you all have understood all the three engines work together. Okay, so we were seeing the ML and the FM. The KG is also working. I did not go into that section because we did not discuss the KG engine till now. One second. Yes, you can do that. One second. Let me. I'm not sure about concepts. Let me just check it. If you can import and all, it will come up over here. Yeah, it is emojis into concepts. Okay, nothing other than that. Synonyms, if you want to import, synonyms are label words for which you can put some synonyms, and it is going to either the label word matches exactly or it matches with a synonym. That is for the word match algorithm. But remember, it's global. So if the same label word is used across multiple tasks, the synonyms will help to go in for that. No, you cannot import the synonyms. So you have to add it separately here. Okay. Okay. Now coming back to the same KG part. So how does the KG engine work? The KG engine, whenever an utterance comes from the user, the working of KG is very similar. By default, it is very similar to the ML engine. So it looks for the similarity in the utterance of the user and the FAQs that are added into the bot. Okay, and if it finds an FAQ that matches with the utterance of the user, maybe the primary FAQ or the alternate FAQs, it will qualify that particular FAQ. And finally, the ranking and the resolver engine declares that as a winning intent, and the response is returned to the user. Okay, but the thing about KG is it does not stop at the first FAQ that qualifies. It keeps on looking for similar FAQs across all the FAQs present in the bot. That means today, if you have 100 FAQs, let's assume a number 100, okay? So let's say you have 100 FAQs within your bot. With every utterance coming from the user, KG engine is going to look through all those 100 FAQs to find similar FAQs. If it finds, after going through all the 100 FAQs, if it sees only one FAQ matches with the utterance of the user, that is marked as a let's say definite match or possible match depending on the similarity. And finally, the ranking and the resolver engine declares that as a willing intent. But there's also a possibility that there are multiple FAQs which contains words which are similar with the utterance of the user. In those cases, all those FAQs get qualified, and depending on the scoring on the similarity, ranking and the resolver engine will qualify the FAQs finally. So if multiple FAQs is qualified by the ranking and the resolver engine, all those FAQs are presented to the user, allowing the user to select the one he wants to proceed with. Okay. Now, why do we have this nature? Why doesn't KG stop at the first question that qualifies? That is basically to keep KG very proactive. Because when you think of an FAQ, the end user may not know how exactly the question is defined within the bot. It's not possible as an end user, it is not possible. Just think of yourself, you are going to a website, which contains all the FAQs of a bank. Okay, you have some question in the mind. What do you do over there? Maybe the question is, given in a different way within that website, but we have the intelligence to understand. Okay, looking at the similarity, maybe the words are similar, so we have that intelligence to understand, okay, the question I have in mind, exactly it may not be mentioned as it is in the website, but the way it is given in the website is similar to what I'm thinking about. Okay, so we can read the response there. So this is the proactive nature. Okay, it may not exactly match, but it can have similarity with the utterance of the user. So KG should consider the similarities. Okay, so if the question does not match exactly, KG should come up with all possibilities, all questions which are similar in nature, so that the end user can select the question for which he wants the answer. So that is why whenever an utterance comes from the user, KG does not stop at the first match. It keeps on looking for similarity across all the questions. And if after looking for similarity across all the questions, one question qualifies, the response is returned. Multiple questions qualify, the questions are presented to the user, and the user will be allowed to select the one he wants to proceed with. Okay. But though this is a very good proactive nature, there is a downside of this. That is, the response time can increase as the number of questions go up. So let's say you have 5,000 FAQs. At times, some banks and some domains, they have a whole lot of FAQs, like 10,000 FAQs maybe. So with every utterance coming from the user, if the KG engine is going through all those 10,000 questions, it becomes the response time of the NLP engine can increase significantly. So how do we train KG better? That with an utterance coming from the user, do not look into all the questions, but look into a section of questions which are similar in nature. By that, what I mean is, let's say you go to a website, okay? You have some question related to credit cards, okay? So you want to apply for a credit card, you want to look for the charges. Do you go through the 1,000 of questions which are there in that particular website? No, we do not do that. We first try to identify the section where all the questions for credit card are given. And once we go to that section, we look for the related question and read the answer over there. We want to simulate that over here. We do not want KG to evaluate all the questions, rather to look for important terms within the question, Okay, and once it gets those important terms, it should look only for the related questions which also contain those important terms. Okay, so instead of going through all the thousands of questions, we are narrowing down the search area of KG. How do we do that? By building the bot ontology. Ontology is a hierarchical structure of the domain terms or the key terms identified from the questions. Okay, so how do you get the domain terms or the key terms? If you look into the questions like how do I apply a home loan? What is a pre-approved home loan? Both of these questions are different. They have different responses. But what is same between both of these questions? Both of these questions are related to home loan. Okay. Similarly, if you look into the next set of questions, you can see what is a personal loan, what is the procedure to repay my personal loan. So both of these questions, what is the subject of these questions? Both of these questions are related to personal loan. I have some more questions on home loan over here. I have some questions on car loan. I have some questions on credit card, some questions on debit card. So these are the subjects, the key terms in the question. And once you get the key terms like this, make a note of it. Okay. It takes time. Remember, NLP training will take time. So you should not rush through the process. Give time to train your NLP. Think about the possibilities. Take help from language experts who can come up with the variations and all, and take time. Okay, don't rush through the process. So make a list of the key terms or the subjects of the FAQs that you have added into the bot, and you will build the bot ontology on the basis of those key terms. So what are the key terms in my questions? I have questions related to credit card. I have questions related to debit card. I have questions related to car loan. Now, for me, it is easy because I keep using this set of questions. But when you are looking into an actual bot, identifying the key terms will take time. Okay, personal loan. There are some questions related to savings account and some questions related to current or checking account. Okay. Now, once you have listed out all the domain terms like this, how do you build the ontology? It's a hierarchical structure. That means the common terms that you find, the common words that you find, put it at a higher level. That is at a parent level. So what I'm going to do is I'm going to create a node at the parent level called card. And under that, I'm going to create two child nodes called credit and debit. Okay, and I'll associate all the questions which have the terms credit and card inside them to the term credit. I'm going to associate all the questions which have the terms debit and card inside them to the term debit. Okay, this will help KG in a way that when an utterance comes from the user, KG will first look for the presence of these key terms in the utterance. Okay, now when the key terms are found, let's say the utterance of the user, no matter what is the question, has the two words credit card inside it. So this section will get qualified. Okay, when this section gets qualified, now KG is going to look for a similar question only within the questions which are associated with this particular term. So KG is not looking into all the questions which are associated with other terms in the ontology. So we are reducing the search area of KG, and this will ensure that KG returns the response within the shortest possible time. Okay, is it clear to you all the purpose of ontology? Because without the ontology also it works. We have seen it till now. But how it will help KG to return the response within the shortest possible time? Is it clear to you all? Okay, now let's build the ontology. So you can see the root term. The first term is the root term, which shares the name of the bot. So in that input file that we were seeing yesterday from where we imported, we actually have the root term over there. Okay, so you can either leave it as it is or you can change it to something more relevant. So if you're changing it, make sure after that, if you are going in for importing questions from an import file, in that case, make sure that you use the name that is given over here. Okay, or the term name where you want to import that question. Okay, now once you have the root term, let's create the first level nodes That is, the first is card. What is the second one? We have car loan, home loan, personal loan. So loan is a common word. So I'm going to put that in a second. So I'm just adding the child notes under card. Okay, so credit and debit. Okay, now I come back here. I add another first level note, that is loan. And under loan, I have child notes, which are car loan, followed by home loan, and followed by personal loan. Okay, and once again I'm going to create a first level node by clicking on the plus sign on the root node. Okay, and this is account, and under that we can have savings and checking, or current rather. Okay, now once you build the ontology, you can build child nodes under this also. Okay, so there's no restriction, but we always say that try to limit the nodes, the total number of nodes to the in the ontology, to maximum 20,000. Don't go beyond 20,000 nodes in the ontology. That might slow down the entire response time of KG, because KG will look through all the nodes to qualify path. So if you have a huge ontology which is going beyond 20,000 nodes, now that is a very huge amount by itself. But if you create something that goes beyond 20,000 nodes, once again to look into all the path, it might slow down the response time of KG. Okay. Now, once you have created the ontology like this, come back to the root node, which will always show you all the questions in the bot, and filter the questions on the basis of the terms. So I'm going to look for the questions which contain credit card inside them. So it filters the question. I'm going to select those questions, drag and drop them to the node to which I want to add. Okay, coming back to the root node once again. This is a repetitive process, so let me just do it quickly. So I'm looking for debit card, select the questions, drag and drop them here. Next, I'm going to look for car loan. Okay, select, drag and drop. Now, once we complete this, I'm going to train KG, and I'll show you all how the ontology helps KG to filter the questions. Okay, so the last set, current account, and then we will take a break. Now, once that is done, all the questions are associated. If you go back to the root node, once again, you get to see all the questions and the name of the term with which it has been associated. It is referred to as the path to which it has been associated. If you hover here, you can see the entire path, that is the root term, followed by the parent term, that is the first level node is account, followed by the child term under it, that is savings. Now, once you have done this, do not forget to train the KG engine, okay, with the ontology that you have built. Once it is done, let's go back and talk to the bot. So I'm just going to use a question for example. Let's say, what is a pre-approved car loan? Okay. You will see the response coming up. This primary question has qualified. If you come to the ML analysis section, this time you can see ML has not done any intent identification. FM engine is not being displayed here because there are no patterns which matches, which tells FM engine which task to qualify. So FM did not qualify anything. But the FAQ section, which is actually your KG section, okay, you can see here there is a section called extracted entities. These are the words which are extracted from the utterance of the user, the words car and loan in the utterance of the user, which were used for qualification of a path. So if you come down here, you can see the path qualification taking place, and this is the path that got qualified. So in the FAQ demystification, you can see the path that got qualified from the ontology. So the path is car, loan. These are the two terms which were extracted, which were used for qualification of this path. And within the qualified path, there is a question which matched with the utterance of the user. So that was declared as a definitive match. And as a result, the ranking and the resolver engine declared that as the winning intent. Okay, so you can see the matched question is this, the primary question is this, that was the intent, or this is the utterance of the user. So from the path that got qualified, it has picked up the question that matches with the utterance. So whenever an utterance comes from the user, the first thing that the KG engine will do is it will try to qualify the path. Okay, how will it qualify the path? It will look for the presence of these terms or these words in the utterance. Now, if these words are found, they are extracted. They will be shown in the extracted entities section. Now, from the path that has got qualified, it will look for the questions that match with the utterance of the user. Now, if it finds a question that matches with the utterance of the user, that question will be declared as the qualified question. Okay, so ontology, basically what it is doing is it is reducing the search area of KG. You can add more than one question to two different paths, but once again, what happens is either your terms, when you're building the ontology, that domain term, you have to check for it. Okay, so it's not advisable that you have the same term again and again. Again, I have card and credit does not make sense. Okay, but I can have something like common terms across the ontology, and there can be questions which use the common terms. Yes, that can be a possibility where both the paths get qualified, but it is not only the path qualification, it is two level of qualifications. That is first the path qualification and then a similar question from the qualified path. Okay, there also, if multiple questions are getting qualified, finally we have the ranking and the resolver engine which will declare the winning intent. If these questions get qualified as a definitive match, both of it will be presented to the user. If the questions get qualified as possible match with a high confidence score, again it will be presented to the user. If it gets qualified with a low confidence score, we will see all these thresholds also. Then the ranking and the resolver engine will ask the user, did you mean followed by the question? And if the user clicks on the question, then it will return the response. Okay. So it can happen, but we try to demarcate questions as far as possible, because the same question in two different places do not make sense. Okay, but similar questions can be there. What is a pre-approved car loan? What is a pre-approved home loan? Both of these questions are very similar, but one is related to car loan, one is related to home loan. And there the ontology will come into play to identify the question correctly, because in one place the utterance of the user will have the words car loan, and one place the utterance of the user will have the words home loan. Okay, so now using the ontology, KG will identify the question correctly and return the response to the user. Okay, that is one of the uses of ontology, where you have very similar questions, but on the basis of the domain terms or the key terms, you segregate the questions, you demarcate the questions, and help KG to identify the correct question and return the response accordingly. Okay. So that is the purpose of ontology. Though without the ontology also we have seen, but in those cases, the possibility of ambiguous identification increases a lot. Okay. Let's take a break of 10 minutes and then we will continue with the rest of the training on the basis of the ontology. It is used in the KG section, but I'll show you, you can also qualify dialogue tasks using KG. So that will come a little later. But ontology is only used in the KG section. Okay. Let's take a break and then continue. Okay, let's continue with the training. So now coming back to what we were discussing before the break, how the ontology helps in identifying the question correctly. Okay, so let's talk to the bot. Like we have seen that what is a pre-approved car loan? First, it looks for the presence of those key terms, and using those key terms, it qualifies a path. And within the qualified path, it picks up the question which is similar to the utterance of the user, and that question gets qualified. Okay, and finally ranking and the resolver engine declares that as a winning intent, and we get to see the response coming back. Similarly, if I say what is a pre-approved home loan, now both of these questions are very similar in nature. Okay, the difference is car and home. Those are the two words which are different. So you can see the response of home loan coming up over here, this question getting qualified, and you will see once again it was the ontology which helped identifying the question correctly. So the extracted entities used for path qualification is home and loan from the utterance of the user, using which a particular path got qualified, and within the qualified path there is a question that matched with the utterance. Now the other path did not get qualified. The path for car loan did not get qualified, though the parent term is common, but the child term, that is the term car, is not present in the utterance of the user. So KG did not look into the questions belonging to the car loan section because another path has qualified, and within the qualified path, it found a question which matches with the utterance of the user. So we are helping KG not only by organizing questions under the key terms or the subjects or those domain terms, also we are reducing the search area of KG so that KG can qualify a section and look for a similar question within the qualified section. Okay. But what happens if I say now, what is a pre-approved, let's say, auto loan? Now, we have not trained KG to understand that auto is a synonym of the word car. Okay, so KG does not have that. KG, which is a part of the NLP engine, does not have the intelligence right now to understand that auto is a synonym of the word car. Okay, so we are saying what is a pre-approved auto loan. So immediately you can see KG comes back with suggestions of two questions. So the bot says select an option and presents both the qualified questions to the user, allowing the user to select the one he wants to proceed with. Now, why did this happen? This happened because right now KG does not have, like I was saying, the understanding that auto is actually a synonym of the word car. So the user can say auto, the user can say vehicle instead of actually saying car loan. Okay, we have not built that intelligence within the NLP engine right now. So what is happening is from the terms of the ontology, only the parent term is found in the utterance of the user. Now, when the parent term is found in the utterance of the user, we do not say that, we do not tell KG that don't look for similar question because none of the child terms are there. We want to always keep KG as proactive as possible. So when the parent term qualifies, we tell KG that, okay, since none of the child terms have qualified from the utterance of the user, so look across all the child terms, okay, all the questions in the child terms, and see if there is some similarity between these questions and the utterance of the user. Okay, since none of the child terms has exactly qualified, okay, so we force KG to look into the questions in all the child terms under the qualified parent term, and if after this particular search KG finds similar questions across the child terms, it will present those questions to the user. This is what has happened over here. You can see the extracted entity is loan, which is actually the parent term. Okay, so you can see against that two paths have qualified. That is the car loan path and the home loan path. Why did these two paths qualify? Because these two paths contain questions which are similar to the utterance of the user. Though none of it matched exactly, you can see the scoring is 89%. That means it is not a 100% match between the utterance of the user and the question as it has been stored within the knowledge graph section, but the similarity is considerable. Okay, so none of the questions match exactly. Similarly, the path did not match fully. Only a partial path qualification took place. So as a result of which both the qualified questions are presented to the user. Now the user can select the question with which he wants to proceed. Okay, so when the parent term qualifies, in order to keep KG proactive, we always say that look into the questions which are there in the child term, since none of the child terms have qualified from the utterance of the user. But here this situation should not have arisen, okay, because when the user says what is a pre-approved auto loan, of course auto is a synonym of the word car, so the home loan question should not qualify at all. Okay, so how do we train KG now that to understand if the user says auto instead of car, that is the path that should get qualified. The home loan path or the personal loan path should not qualify at all. So here on the basis of the ontology, we are going to do some trainings. So we come to the term car over here. We click on the settings button and here we provide some synonyms of the term car. So synonyms like auto is one of the synonyms, okay, or let's say vehicle is one of the synonyms, or four-wheeler is one of the synonyms. You can continue the synonym as you want. Okay. Now, once you have defined all the synonyms, there's no restriction on the number of synonyms. Okay. Once you have defined all the synonyms, click on the save button to save these synonyms. Similarly, I come to home. Okay, you may or may not, but it is always good to give synonyms. You know, these are certain trainings nobody will tell you about, but you have to consider these, that the variations in the words. Okay, so this is very important part when you are training the NLP engine. So let's say for home, the user says house, or the user says property, or the user says land, or let's say the user says apartment or villa. Okay, so you can think of all the possibilities, put it as a synonym over here, and once you have done that, click on the save button. Okay, I want to show you all the changes, how the bot is using the synonym to qualify the question. So I'll train it right now. Actually, you should be doing as much as training as possible and then go and click on the train button. But since in the training session, we are seeing what happens before the KG training, what happens after the KG training. So with all the changes one by one, I'm going to keep on training the KG engine. So let's come back over here. And this time, let us repeat the same question. That is, what is a pre-approved auto loan? Last time, it presented a choice of two questions, okay, allowing the user to select the one to proceed with. But this time, you can see the car loan response has been displayed to the user. Now, how did this question, this primary question, get qualified? If you come to the NL analysis section and to the FAQ section, this time in extracted entities, you can see the two terms, auto and loan, extracted, which were used for path qualification. I'll take your question a little later. Let me just explain this. Okay, so auto and loan, which were extracted from the utterance of the user, and using those two extracted entities, you can see the path that got qualified, that is the car loan path from the ontology. How did car loan get qualified? Because auto is a synonym of the word car. Okay, so you can see over here, the word auto has been treated as a synonym of the word car. So using the synonym, this particular path got qualified. Within the qualified path, there is a question that matched with the utterance of the user. So KG has returned the response of this question. So this time, it did not consider the home loan section because we have expanded the training or the understanding of KG by providing synonyms to the terms. Okay. Untrain or roll back, you cannot do it directly. You have to remove these trainings, okay, whatever you have done, and click on the train button again. So we do not have any option where you say untrain and you undo all those trainings that you have done. One way is, before you do some training, you can create a version, okay. Maybe today you have done some training, all those trainings are working fine, and tomorrow you need to make some changes in those training, but you're not sure the changes will give you a positive output or not. So in that case, you can create a version, which I'll show you later on how to create a version, which will store all the current configurations of the bot. Okay. And after that, you can make changes to anything, to task configuration, to NLP training, whatever. And if you're not happy with the changes, you can restore the version that you have created. So that is an rollback kind of a thing that we have. But here itself, you do not have any untrain button to do it. Okay, I'll show you all how to create versions and all towards the end of today's session. Okay, so you can see KG is using the synonyms of the terms to qualify a particular path. Consider synonyms. Again and again, I'm seeing this because I have seen many a time, as we do not specify, people do not consider synonyms. But these are certain things that you should consider when you are training NLP. The variations in the words, okay, it's very important. Let's say the user asks, I'm using these two questions as an example, the same behavior across all the questions. Okay. So what is a pre-approved loan? Okay. So I don't say car loan. I don't say home loan. So I just say what is a pre-approved loan. Again, KG will come back with a suggestion. Why? The parent term has qualified. None of the child terms qualified. So KG looks into all the questions which are associated with all the child terms under this particular parent term. Two questions which are similar to the utterance of the user. Both of those questions are qualified by the ranking and the resolver engine and presented to the user, and the user can select the one he wants to proceed with. So you can see the extracted term is loan over here. Both of these child paths get qualified. You can see the term loan is found in the utterance because it is enclosed within the square brackets, which means this term is there in the utterance of the user, but the child term is not there in the utterance. So partial path qualification is allowed, and you can see through partial path qualification, there are two questions in these partially qualified paths which match with the utterance of the user. KG presents both of it to the user, rather ranking and the resolver presents both of it to the user, allowing the user to select the one he wants to proceed with. This is once again the proactive nature of KG. Most of the organizations, they like to go ahead with this proactive nature because users may not exactly know that how the question has been stored within the bot. So he can ask a question like this where he does not say whether it is car loan or home loan. So it is always good KG presents the choices. But if you're very restrictive that if the user does not say car loan or home loan, these questions should not qualify. So any questions belonging to car loan, user has to specify the words car loan in his utterance. Similarly, for any questions related to home loan, the users have to specify the words home loan in the utterance. Okay, so we are applying a restriction on KG, that is unless and until the child term is present in the utterance of the user, do not look into the questions associated with that child term. Okay, how do we do that? We come to the settings of that child term and we change the term type to a mandatory term. Mandatory term means that term or synonyms of that term has to be present in the utterance of the user for that particular path to qualify. And only when a path qualifies, then the questions associated with that particular path is accessible to KG for the similarity matching. Now, once we make all of these terms mandatory terms, let's train KG and repeat the question once again, which was coming back with a suggestion. Okay, so this time you can see intent identification has totally failed. Okay, though the parent term is present, but the mandatory terms, which are the child terms, they are not present in the utterance of the user. So none of these child terms qualified. And since it is mandatory term, that means the path has to qualify. Exactly. Okay, so the partial qualification, we have removed that capability of KG. So since these terms are not found in the utterance of the user, neither synonyms of these terms are present in the utterance of the user, none of the terms qualified, as a result of which no similar questions were found, and KG comes back with the intent identification failure. Sorry, not KG, the bot comes back with the intent identification failure response over here. Okay, so that is the purpose of mandatory terms, though it helps KG to identify questions only when specific terms are present. But if you think in the other way, you are removing the proactive nature of KG, you are imposing rather a restriction on KG, okay, that this words has to be there in the user's utterance. So consider it. Do you want restrictions like this? The restriction helps KG to identify questions correctly, but again, it also removes the proactive nature of KG. So before you make terms mandatory, consider it. Do you really want it? And if you see no, it is helping you, then you can always make terms mandatory, so that only if those words are found or synonyms of those words are found in the utterance of the user, the path will qualify. Is it clear to you all the purpose of mandatory terms? Okay. Now coming back to the root node. Okay, so you can see all the paths over here, which nodes it is associated with. If you want to see the questions which are still there at the root node, you have not associated them with any of the paths that you have defined in the ontology, click on the second tab over here. Okay, so it will show you the questions which are still there in the root node. You will come across situations like this when you have standalone questions. Okay, so very different questions, but single questions by itself. Okay, it's not advisable for single questions like this to build individual terms in the ontology and associate the question. Don't unnecessarily increase the size of the ontology unless and until you find a few questions related to a subject. Do not create a term and associate, because increasing the ontology unnecessarily might again slow it down, okay, the response time, because KG will first try to look for a qualified path over here and then look for a question within the qualified path. So if the the ontology is quite big, it will take time to browse through the entire ontology. So these standalone questions, where should you keep it? Should you keep it at the root node? You can keep it, because all the questions in the root node are always accessible to KG. So once an utterance comes from the user, KG first looks into all the questions present in the root node, whether there is some similarity, and along with that, it looks for similarity into the questions which are coming from the qualified path in the ontology. So root node questions are always accessible. But if you want to organize these questions together into a term in the ontology, okay, ontology also helps you in, organizing the questions correctly, okay, under particular subjects. You're organizing the questions. So today, if I want to see how many questions are there for home loan, I don't have to go through all those 30 questions which are there. I just need to click on home loan and I get to see all the questions over here. Okay, so it also helps you in organizing questions correctly. So instead of keeping all the standalone questions over here, where every time you want to see, you have to come, click on this and see how many questions are still there in the root node, you can create a term. Okay, let's say I just say general questions. Okay, so I name the term as general, and what I do is I come here, I pick up this question or whatever, how many standalone questions are there, just select them and I drag and drop it over here. So that will help. Like if I want to see what are the questions other than these, subjects, what are the other questions which are there in this particular bot, I just click on the general section and I see all the questions. But what is the disadvantage in this case? The disadvantage in this case is right now, if I train KG and I ask this question, is mobile banking available? You will see KG will not return the response of the question. That is, that question will not get qualified. Okay. You can see intent identification has failed. Why did that happen? This question is there. Okay, it should be an exact match with the utterance of the user. But since this question is associated with this term is not found in the utterance of the user, path qualification has failed. This question is unreachable by KG. Okay, so KG does not get access to this question. So what do we do? Okay, one is I take it back to the root node, but I want to keep all the standalone questions within a particular section in the ontology to organize the questions properly. So user is never going to say, I have a general question, is mobile banking available? That is not the way how user will ask the question. So how do I tell KG that this term should not play any role in path qualification? So whatever questions are present under this term, internally treat them as they are present in the root node itself, so that these questions are always accessible whenever an utterance comes from the user. So if you have a condition like that, come to the settings of that node, change the term type to an organizer term. The moment you say that it is an organizer term, it means that term will not play any role in path qualification. Okay, so internally, it will be like this question is still present under the root node. So let's repeat the question once again and see the analysis of the NLP engine. So you can see this time it has returned the response, and if you come to the NL analysis section, go down to KG, you can see extracted entities, nothing over here because no path qualification has taken place, and you can see the qualified question is this, but internally it is taking that the question is still present under the root node, though we have associated the question under an organizer node. Okay, so you can create organizer nodes for putting few questions or organizing few questions together, but these organizer nodes will not play any role in the path qualification. Okay, any questions on this? Okay.
One question.
Yeah,
from a
please go ahead.
performance standpoint, what is a reasonable number of FAQs that can be assigned to each node?
We say don't go beyond 25 FAQs under each node.
25.
Okay.
Okay.
Yeah.
Okay,
25 questions within each node. Okay. If it is more than 25,
node,
then
yeah.
try to create a child node depending on the similarity and associate questions there. Okay.
Yeah, and one more question. How many child nodes can you create? Like, can you do a
It's
child
not
within a child within
restricted.
a child?
Child nodes are not
Okay.
restricted, but like I was telling, try to restrict the total number of nodes to maximum 20,000. Actually, don't go beyond that. Okay, which is actually a huge amount. Okay, but yeah, when you're creating the ontology, you will see maximum you can go up till 5 to 6 child nodes. Beyond that, you cannot think of things also. Okay. Because the more you are segregating, the more that path qualification and all these things comes into play. So in real life, we have seen maximum 5 to 6 child nodes coming up like that. Okay, in a given path, not beyond that.
Yeah, what I mean to ask is, like you have defined card, and within that you have credit. So under credit, can I do platinum and gold as sub?
Yes. That is what. That is how I'm saying. Yeah, maximum, under a child, another child. So we have seen maximum, 5 to 6 nodes going like that. Beyond that, you will see you find it very difficult to come up with, more child nodes. Okay.
Got it. Thank you.
Now coming back to the home node section. Okay, let us discuss another term, that is the tags, which we were talking about yesterday, important terms within the utterance of the user. Now here you have two very similar questions. How do I apply a home loan? How do I repay a home loan? Both of these questions are very similar. They belong to the same path, that is the home loan path. What are the important words within these two questions which identify the questions correctly, okay, or uniquely? That is the word apply in the first and the word repay in the second question. Okay. Now, if you have situations like this where you have very similar questions, they belong to the same path, but one word or two words maybe tell you that what question to be qualified. Okay. How do you mark those words as important words for qualification of that question? One is, you can think about create child notes over here. Okay, so I can create a child note called apply, I can create a child note called repay and associate the question. But since these are single questions, okay, if there were multiple questions related to application of home loan, I could have created a child note. It would have been a good approach to do it. Okay. Similarly, if there are multiple questions related to repaying home loans, we can create a child note and associate the questions there. But when you're talking about single questions, I would not suggest, or we do not suggest from code, that create nodes in the ontology. For single questions, there are different ways of handling it. One is, since this is a single question, but within this question, there is an important term which should be used by KG to qualify this question. Okay, so what we do is, we click on this and we say that this particular term, the word term, is a tag to qualify this question. So when you click on the line below the question, you can add tags over here. Tags are important words which, if present in the utterance of the user, will help the NLP engine, in this case the KG engine, to qualify the question for which that word has been tagged. Okay, so here I can say the word apply is an important word to qualify the question. You can see the platform is coming back with a suggestion. The bot is coming back with a suggestion of important terms. You can also type in, okay, at times, words like how and why, okay, or what, okay, how to take home loan, what is a home loan. Now, the words how and why are very important to segregate both the questions. Okay, so you can tag those words like how and why, but maybe the bot does not suggest those words as important words. You can type in the word. That is also possible. Okay, so here what I do is I select apply as a tag. And once you select a word as a tag, you can leave it as it is. That means this word by itself, it is present in the utterance of the user, will help KG engine to qualify this question only. Okay, but once we have created a tag, we can do some optional trainings also on the basis of this tag. So click on the tag. You can define some synonyms of those words. One second, let me just refresh my token. Okay, just click over here. Okay, and we are going to define some synonyms for apply, like take is one of the synonyms, avail is a synonym. I would suggest refer to online dictionaries to find out, relevant synonyms of a word, so that you can, handle all the possibilities. And if you want that the presence of that word or the synonyms is absolutely mandatory for qualification of this particular question, then you can see the tag usage is a mandatory one. Okay, that means that word has to be present in the utterance of the user, or synonyms of this word has to be present for this particular question to qualify. So other than the path qualification, we are adding additional words as rules for qualifying this particular question. In the same way, I come to this question, and here I say the word repay is important to qualify this question. And if I've added a tag, I can always go in for some additional training, like I can make it a mandatory tag. But mandatory, once again, is a restriction. That means that word has to match. Okay, so remember that whether you want to make mandatory terms in ontology, mandatory tags, that you should consider once. Okay, and coming to synonyms, repay, so I can say close is one of the synonyms, or prepay is one of the synonyms, and you can continue the list as you want and see it. And once you have done that, let's click on the train button and let's start to the bot. Okay, so you can see the response coming up over here. If you click here, let's go down to the extracted entities which were used for qualification of this question. You can see home and loan are the terms for the path qualification in the ontology. An additional word take has also been considered for qualification of this question. Why was the word take considered? Because take is a synonym of the tag that we have defined, that is apply. It is a mandatory tag. That means this word or synonym of this word has to be present in the utterance of the user for qualification of that question. How do you understand it is a mandatory tag or a mandatory term in the ontology? The asterisk before the tag name or the term name tells you it is a mandatory tag. So using all of these conditions, KG has qualified this particular question as a definitive match, and ranking and the resolver engine declares that as a winning intent. So the more you increase this number of mandatory tags and all, more are the rules you are defining for KG to qualify particular questions from the or from the set of all the FAQs that are added into the bottom. Is it clear to you all the use of tags over here? Okay. Now, the last training that we can do is in KG also we can use patterns. So just like we have used patterns for the FM engine to qualify dialogue tasks, to handle alternate questions. Okay, so one way is you add your alternate questions over here. Another way is to handle multiple alternate questions. You can also define patterns. Okay, you can go in for a combination of multiple patterns and alternate questions in order to handle all the variations in the utterance of the user. So a whole lot of training. You are handling variations with synonyms, you are handling variations in utterance of the user with alternate questions, you are handling variations through tags of important words, you are handling variations through patterns also. And why so many approaches? It is because when you are talking about FAQs, there can be various ways in which the user can ask that question. So you have to identify what is the best approach. These are all the different ways which are possible, but what is the best approach, that you will look into the variations and then you can identify what is the best approach and train KG accordingly. But how do you add patterns over here? Your pattern has to start with a double pipe symbol. It tells you over here it is a pattern, and I have a pattern ready. Let me just copy it and put it there. So what does this pattern mean? This pattern means, the word method, policy, process, action, or strategy has to be present in the utterance of the user. We have used the same operators. So these are alternate words of the procedure. Okay, so you can see what is the procedure to repay my personal loan. The user can say method or process or policy or action or strategy. The word repay, these are some synonymous words like refund, return, pay back, or settle up. Now you can see the underscore between pay back and settle up. What does this underscore means? This means no other word between these two words. This is defining a group of words. At times, in this case, like settle means something, up means something different. But when they come together, settle up one after the other, they actually work as a synonym of the word repay. Okay, similarly, pay back. Pay has a different meaning, back has a different meaning, but pay back together means synonymous to repay. Okay, so what you are doing with an underscore is telling the NLP engine no other word between these words. Okay, you can use this underscore for your FM patterns also. Okay, so multiple words separated by underscore, which implies no other words between these words. It is used to define groups of words which will come together, and that group of words gives you a specific meaning. Okay, so that is why we have used the underscore over here, followed by personal loan. So see the number of alternate questions that can be handled by a single pattern like this. Once you define patterns, you can have multiple patterns, you can have some alternate questions and patterns, combination of all of those things. But once you have done that, click on save and never forget to train KG. So you can see the response has been returned and it has been qualified. The FAQ got qualified using the pattern that we have defined. Okay, so you can see I have used one of these words, settle up, coming one after the other. Okay, and here if you go back to NL analysis, you can see path qualification is the ontology path qualification, and from the qualified path, the primary question that got qualified using a pattern that has been defined. So you can define patterns here, but remember one thing, your primary question is the question in its simplest form. So that cannot be replaced with a pattern. Okay, your primary question has to be a clear question in its simplest form, but you can handle alternate questions using patterns. Okay, is it clear to you all? Any questions on this? And within these patterns also, you can use concepts that you have defined in the bot synonym section. For that, to use those concepts, you have to first enable that list. So come to manage synonyms from these three ellipses and first enable the bot synonym section. Only when you enable this section, then you can use the concepts that you have defined in order to build patterns for FAQ qualification. Any questions on anything we have discussed till now? Okay. Now you can see the power of KG is quite high. Okay, it combines both the ML and the FM approaches. Okay, so at times we would like to use KG only to qualify dialogue tasks, because right now what we are doing is we are using KG only to qualify FAQs. But since we have a whole lot of training possibilities, where one of the very important things is those tags and all, where you can mark important words within the utterance of the user, the presence of which will lead to qualification of FAQs. This is something you cannot do in ML utterances. Okay, you cannot mark important words. Okay, these words have to be there. Doesn't matter what other words are there. So those kind of things becomes difficult when you are going in for the ML training, and ML needs a huge lot of utterances. When you have a limited number of utterances, it is not good to train ML with this. So in those situations, we can use the KG also to qualify dialogue tasks. And all the training that we have discussed till now, like ontology, which is important terms and tags and term usage with mandatory terms and all synonyms. So you can see it's a combination of all the training that we have discussed till now. how do we use KG to qualify dialogue tasks. So when you are adding a question, till now what we have seen is these are static responses, okay? But if you want to qualify a dialogue task as a response of an FAQ, then select task where you are defining your FAQ, select task over there, select the task you would like to qualify, and in add utterances, you can add all your utterances and you do all the training that is possible, okay? Whatever we have discussed till now, like tags, synonyms of tags, mandatory tags, okay? Associating this with a term in the ontology, so that the presence of the words open account leads to the qualification of a path from the utterance of the user. So all of those things can be done and you can qualify a dialogue task, which is a response of an FAQ. Okay, so you can use the power of KG to qualify dialogue tasks as well. Okay, any questions on this? Okay, but it cannot be a combination, remember that. Okay, you want a static response followed by a dialogue task, that cannot be the thing. Either a static response or a dialogue task. Okay, so any one of it as the response of FAQs. Okay, so these are all the different ways in which we can train the NLP engines. But we have another engine, that is ranking and the resolver engine. And let's see how the ranking and the resolver engine works. So let me just copy a question from here. So one way of seeing is like we were seeing from talk to the bot, but the talk to the bot comes up with a whole lot of parameters which we may not need at this point to understand in details. So to see a summarized view of the NLP analysis, we go to the testing module now, and there we have something called the utterance testing. So in utterance testing, you can provide test utterances over here and see a summarized view of the NLP analysis and see how the intent identification is taking place. So once you provide your test utterance, press and enter, it will process it. It will show you the intent or the FAQ. Intent means either dialogue task or FAQ, whatever, which is getting qualified. And here you will get to see the summarized view of the entire NLP analysis. So let's look at that. It takes a little time to generate the summarized view. So you can see the machine learning engine had qualified the check balance task. Okay, how did it qualify? Click here. You can see the similarity score is 0.35. Okay, that is 35% similarity score between the training utterance and the utterance coming from the user. If you want to see the threshold configurations, you can click here and you can see the definitive score over here, that is 95%. 30% is the minimum level that we have seen. Similarity score is 35%, so it got qualified as a possible match with a low confidence score. Fundamental meaning engine has qualified open account task. Okay, so if it is qualified through a pattern, you know it will always be a definitive match, because a pattern has to match as a whole, and if a pattern matches, FM engine is confident that is the task the user wants to perform. But when you see a possible match, it is the word match algorithm that takes place, because the task which has qualified is open account, and you can see the words open and account present in the utterance of the user that led the fundamental meaning engine to qualify open account as a possible match. KG engine qualified this particular FAQ as a definitive match. The path got qualified. Under the qualified path, there is a question that matched with the utterance of the user. You can once again see the thresholds over here. So you can see the minimum and the definitive match levels. 60 to 80% is taken as minimum similarity, okay, and beyond 80% is high, and 90% above is definite. Let me just quickly show you all that. Okay, I'll show you all that. Okay, so KG qualifies this particular question as a definitive match. And finally, you have the ranking and the resolver engine, which declares the KG, that is the FAQ, as the winning intent and disqualifies both of these style of tasks. You can see the reason for elimination over here. That is higher scoring. These got disqualified because there is one intent that was qualified as a definitive match. Okay, so that was given a higher precedence over all the other intents that got qualified as possible matches. Okay, let's change the utterance. Okay. So you can type in multiple utterances like this and see which tasks are getting qualified and see the summarized view of the NLP analysis also. It helps you very easily to understand. So you can see make payment task. Once again, check balance task had got qualified. You can see open account task by fundamental meaning engine qualified over here due to the similarity between the training and that is due to the presence of the label words, that is open an account. Here partial this thing. Only the word account has been found in the utterance of the user, so that leads FM engine to qualify this task as a possible match, but make payment task got qualified as a definitive match. And if you click here, you will see this was the pattern that helped it to qualify it as a definitive match. So finally, ranking and the resolver engine declared this as a winning intent, and the reason it eliminated these tasks was because a definitive match was found. You can see the reason of elimination over here. It depends on you. Okay, I won't say it is a good practice always, but yes, we by default it will remove it with the low percentage. Okay, there is a difference in the calculation. I'm coming to that. Okay, so by default you will see the ranking and the resolver engine will eliminate the ones with a very low score. Now, how does it eliminate? Now, do you want to give preference, precedence to all the qualified matches? Irrespective of the score, we can do that also, but it depends on what approach you would like to take. Okay, so I won't say every time it is good. By default it does it. The ones which are getting a very low score, it will eliminate, and how it eliminates, I'm coming to that. Okay, now coming to check balance once, because check balance had got qualified using by the machine learning. When you come here, if you want to see which task led to the qualification of the check balance task, if you see here, you can see this was the utterance which led to the qualification of the check balance task by the machine learning. Okay, sufficient fund. The word fund is present in the utterance of the user, so that led the ML engine to qualify it. Okay, so that is how you can see which utterance. Now coming to the question that you were asking, that is, let's say, let's think of something. I'll just make a small change, okay, before we proceed, so that I can show you all multiple possible matches. I'm just removing this, okay. I'm just making this change to show you all multiple possible matches, okay. Let's see what is the response of this. Okay, now see payment from account. okay, which has led the task to be qualified. Both of these tasks got qualified. Fundamental meaning engine using the word match algorithm has qualified both of these tasks. Okay, so when it is using the word match algorithm, you can see the scoring is taking place over here. So you can see the words matched, that is label words matched. For each label word matched, it gives a score of 250. Okay, so one of the label words have matched, that is out of open account, the word account is found. So one label word match, so 250 is the score. And the word coverage, okay, so at which position the word is found. Out of the total number of words, okay, so there are 3 words. Out of that, one word has matched with the label word. So there's an internal calculation, that is what it shows you. Okay, and exact word, whether the label word has matched exactly with the utterance of the user or it has matched by a synonym. Okay, so these are the different factors which it considers for the label word match. Similarly, for make payment, you can see a similar kind of a scoring over here. So both of these tasks are getting qualified, and once these tasks are getting qualified, okay, it comes to the ranking and the resolver engine, which rescores this. Now, when it is rescoring, ranking and the resolver engine uses a similar scoring pattern like the fundamental meaning engine. There is some bonus calculations also. Bonus calculations is position of the word in the entire utterance. Okay, so if the matching word is found towards the end of the utterance, it gets a lower score. If the word is found towards the starting of the utterance, it gets a higher score. Okay, then sentence structure, that is how many words are noun, how many words are verbs, and also those things matter. Then order, order bonus. Order bonus is the order of the words. So if the name of the task is open account, okay, and in the utterance of the user you have the word account first and the word open later on, that will get a lesser score compared to if the words come in the same order. So that is the order bonus. Match bonus, if the previous task matched and the next task matched are the same, there is a bonus for that. So a lot of bonus calculations take place over here, as a result of which open account task has been given this score and make payment task has been given this score. Okay, now after the scoring takes place, you can see it is the bonus that is different for both of this. This has got a higher bonus and this particular task got a lower bonus over here because of you can see here the position of the word is different. So you can go through these and see how it is different, but these are some internal calculations that take place. Okay, but after all of these, you can see that the two scores are different and this one is getting eliminated. Why is this getting eliminated? Because the ranking and the resolver engine, when it gets multiple possible matches, it will rescore, and from the task which has got the highest score, it will calculate 2 percentile of that higher score. Okay, so the 2 percentile of this particular score, all the other intents which should get qualified should have a score within that 2 percentile of the highest score. Now, if you can calculate 2 percentile of this, you will see this score is below that level, okay, below that range. So that is why the ranking and the resolver engine has eliminated this, okay. So that 2 percentile is a default setting that we have. Whenever there are multiple possible matches, it comes into play only when you have multiple possible matches. So ranking and the resolver engine will rescore all of them, and from the highest score it will calculate 2 percentile, and it will qualify all those tasks which have a score within this 2 percentile score that has been calculated. If the next score falls below that particular level, the task will get eliminated. Now, there are two things. At times, this is perfectly fine. At times, we would like to increase this range. That is, more tasks should get qualified. The more the possibility we present to the user, the more is the chances the user can select the task he wants to perform. Okay, so if you want to increase that range from 2 percentile, you want to increase it, then come to thresholds and configurations over here. And from here, come to the ranking and the resolver engine. And this is where you have this 2% calculation. You can increase it up till 20%. So if the highest score is 10,000, 2 percentile of that will be 8,000, right? Because 2% of 10,000 will be 2,000, right? And if you subtract that, you get 8,000. So it should be within that particular range. If you increase that up till 20%, I guess 2 percentile is 9,800, sorry. Okay, if you increase it till 20,000, then you the 20%, you get 8,000. Okay, as the 2% at 20 percentile. So your range is increasing. Okay, the number of tasks which will be considered is increasing significantly over here. So you can increase this over here. By default, definitive matches are given a higher preference. So if you get a definite match, ranking and the resolver engine will not look into the possible matches. But if you want ranking and the resolver engine to present the possible matches along with the definite matches, you can disable this preference of definite matches. Okay. And if you don't want ranking and the resolver engine to rescore, then you can disable that also. Okay, so these are the configurations for the ranking and the resolver engine. Okay, so this is how the ranking and the resolver engine actually works. Whenever an utterance comes from the user, it is going to first the intent identification engines will work. Then finally, the choices or the winning intents or the qualified intents will be sent to the ranking and the resolver engine, where it will, if there are definite matches, they are the winning intents. Possible matches, rescoring takes place. Then the elimination takes place depending on the cutoff score that is calculated. And finally, the winning intent is declared. Is it clear to you all? Any questions on this? But I would not suggest you all to go and make changes in the thresholds right at the starting, because you need to understand these calculations very well. It is good to know where it is happening, but if you want to do it, be careful, take a backup before you make the changes, so that if you're not happy with the changes, you can always restore back the default values. Okay. Now coming back over here, the question that we had, how can I open a current account? This is the last thing before we go in for testing the bot. I just changed this. Okay, how can I open a savings account? So the moment I make this change, let's see the difference in the winning intent. Last time it was the FAQ that got qualified. This time let us see what is getting qualified over here. So you can see the open account task getting qualified. The KG question was qualified partially because of partial path qualification. You can see the word current is not present in the utterance, and using the the parent term qualification, this question has qualified, but the child term was not present in the utterance of the user. So it is a possible match by KG engine, but when it came to the ranking and the resolver engine, the dialog task was declared as a winning intent. Now, this is the default behavior of ranking and the resolver engine. That is, whenever there is a conflict between a dialog task and an FAQ, like in this particular case, okay, both of the scores are very, close, though this is lesser than 2 percentile of this, but ranking and the resolver engine will always give a higher score to the dialog task compared to the FAQ. That is the default behavior of the ranking and the resolver engine. But there are times where we would like the FAQ to qualify and not the dialog task. Because when the user says, how can I open a savings account? Of course, the user does not want to open an account. Okay, he's asking a question. Here, the rules of the language come into play. And we know that in English, if a question starts with a how or a why or a what or a when, these are actually questions. These are not statements to trigger a particular task. Okay. So we have to tell the NLP engine that since the utterance of the user started with these words, give higher precedence to the FAQ and not to the dialogue task. Okay, the default behavior is ranking and the resolver engine will always give a higher score to the dialogue task. How do we reverse this? For this purpose, come back to the training, and here you have under not into the training, to the advanced settings, and here you have something called negative patterns. Patterns by default are used for qualification of dialogue tasks. Negative patterns are used for elimination of qualified dialogue tasks. Once you enable negative patterns, come back to training, and when you come to the patterns section, so let's go to the task. When we go to the pattern section, you get an additional tab called negative patterns. Click on that and define the patterns which will be used to disqualify the qualified dialogue task. Okay, so I can see over here, if the utterance of the user starts with a how, okay, or we can use those operators also, like it starts with a what or a when or a why. Okay, so if the utterance of the user starts with any one of these, then if the open account task has been qualified, it should be disqualified. Okay, so once you do that, you can also build a concept and use a concept over here for the negative patterns. And once you do that, let's repeat the same question and see the winning intent. So this time you can see the FAQ has qualified, though once again all of these were qualified as possible matches, but at the ranking and the resolver engine level, open account was still given a higher score, but it got eliminated due to the negative pattern match. So which was the negative pattern? If you hover your mouse over here, you can see the negative pattern that I had defined. It was used to disqualify the dialogue task. Negative patterns are used by the ranking and the resolver engine to disqualify dialogue tasks. So maybe the dialogue tasks got qualified as definite matches or possible matches by the intent identification engines. But finally, if you want, due to the presence of certain words or nuances of the language, you want to disqualify the qualified dialogue task, then you can define a negative pattern for that task. And the negative pattern will be used at the level of ranking and the resolver engine to disqualify dialogue tasks. Negative patterns cannot be defined for FAQs because by default FAQs are not given the priority. Okay, so negative patterns come into play when we want to give other FAQs or other dialogue tasks higher precedence over the qualified dialogue task. Default is the first task, then FAQ. No, this shows over here depending on the score. Okay, and the default behavior of ranking and the resolver engine is to give a higher score to the dialogue task. Okay, so depending on all those parameters, whichever dialogue task gets a higher score, that will be displayed on the top. Followed by it is in the descending order of the rank scoring actually, and you will see always the scoring of the dialogue tasks is more compared to the scoring of the FAQs. Okay. Any other question? No. So ranking this patterns, negative patterns always to eliminate some qualified dialogue task. Okay, so this is one more training that you can do. But this is not the only testing you should be doing before you deploy a bot. You should be testing the bot as much as possible. And for that, you can create an input file like this, where it's a CSV file that I have created. These kind of input files can contain up till 10,000 test utterances. So there are 4 columns over here. We are also going to test for entity extraction. So you can see I have put the utterances here, the expected intent with which it should be matching. Okay, if there are entity values in the utterance, I want to also see whether NLP is able to extract the entity values from the utterance of the user or not. So I have put the name of the entity and the expected value to pick up from this utterance and store within the entity. If there are multiple entity values, then put all the entities one after the other in different rows and the expected value from the utterance to be stored within the entity. Okay, remember the name of the intent and the entity name should match with the way these have been named within the bot. Now, once you do that, save this file, and now let's go to the batch testing and upload that file. So we come to new test suite over here, give a name to it, let's say, okay, add a description. Description should be the name of the developer, or maybe the date and time of the test and things like that, relevant details, okay, not something like this. And then you can upload your data set. So you can either go in for a JSON format if you want to see how the file should be created, download the sample, remove the dummy data, and provide your own data over there. I have a CSV file. Okay, so I'll just click on CSV. If you want to see the order in which the column should be defined, download the sample, remove the dummy data, and put in your own data over there. My file is ready, so I just click on choose file and select the file. Okay, so once the test has been created, let's run the test. Okay, so we just click on run test suite, which will trigger the test. Okay, and it will execute each of those utterances over there, and it will come up with a report as to how many intents were correctly identified, and if there are failures in entity extraction, you will get to see that as well. So now you can see intent recognition success percentage is 73. It is not 100%. That means there are some failures. Similarly, entity extraction success percentage is 66.67. That means there are some failures. Let's download this report from here and look into the details. Okay. So on the top, a few rows which will show you the threshold configurations and the date and the time of the test and all. Let's look into the details and understand what is failing and why it is failing, and how you should go about with it actually. Okay. So first, the intent identification part. Let's concentrate on that. And okay. So this was the utterance. This was the expected intent as we had put in the test file. This is the intent that got qualified by the NLP engine. Okay. And if the expected intent and matched intent are not the same, the result type is false positive. Okay. FP means false positive. That is, a particular intent was expected to be matched, but the actual intent that got matched is not the same. So the result is a false positive. Now, what do you do about situations like that? Do I have funds in my account? Of course, it should be the check balance task. But what got open was the open account. Let's copy this utterance. Okay. Let's go back. Either you can do it from utterance testing and see which NLP engine is qualifying the task, but I'll use talk to the bot because utterance testing will take a little time to generate that particular summarized view. So it will be quicker for me if I put it over here. And you can see the open account task qualified. Let's go to the NLP analysis part, and you can see ML engine has qualified open account task. Okay, FM engine has qualified open account task using the word match algorithm, which you can see from here. The 7th word has matched with the label word. Okay, so the check balance task has not been qualified at all because we did not train check balance to handle this utterance. Okay, so what do we do over here? Okay, either you can go in for adding an ML utterance now, or what you can do is you can also go to utterance testing. Let me show you all one thing. Okay, either you can go and add it to ML utterance, you can define a pattern to handle this particular failure, or what you can do is you can come to utterance testing as well, and once you see the output of this, okay, you can see this is the matched intent. You can see mark as incorrect match, okay, because this is incorrect. Okay, now what do you do after that? I will select the intent for which I want to add this as an utterance. So I come to check balance task, okay, and once we see that check balance task, it's a task to be qualified. One second, it takes a little time. What it does is it adds this as a training utterance for this particular task. Okay, so it takes a little time. Utterance testing will take a little time. So you can see for check balance task, you can add this as a training utterance. Okay, so either you can add the whole thing, or you can just remove a few words like do I have, you do not need it. So you can remove those words, whatever way. You can just click on save to add that as a training utterance for the check balance task. So from where are you doing it? You are doing it directly from utterance testing. Instead of coming to training, you could have done that also. Come to training and go to check balance and add that as a training utterance. Once you have done that, click on the train button to train the ML engine. So this is how you should be doing it. You can either add it as a training utterance, or you can define a pattern to handle it. But look into the failures over here. True positive means the expected intent and the matched intent are the same. False positive means the expected intent and the matched intent are different. Okay, so here you can see another false positive. And if you get FN, that is false negative, there can be situations where we were expecting an intent, but no intent was matched. That is failure in intent identification will be represented as an FN. So if you see false negatives, then try to change, train one of the NLP engines to handle that particular utterance coming from the user. Okay, so these are the different ways in which you should be looking into the, the output of that particular batch test and train your NLP to handle the failures or the incorrect intent identification. Is it clear to you all? Any questions on that? Okay. Now coming to the entity extraction part, you will see by default our NLP engine has the capability to extract entity values from the utterance of the user. Now let's say I say over here, check balance for account, let's say 10, okay? So you can see check balance task getting qualified, and then the bot is directly asking me, do you want to proceed with account number 10? So from where did it get 10? It did not prompt me. So here you can see account ID entity has picked up the value of 10. So it has picked up this value from the utterance directly. Okay, so if you come here also, you will see the entity account ID is holding the value of 10. That means the NLP has the built-in capability of extracting entity values from the utterance of the user if the user provides the input within the utterance. Okay, if it is not providing the input, then the bot will prompt the user for the entity value. Now, what controls this? Whether it will prompt the user for the entity value or not, or whether it will extract from the utterance of the user, what prompts this? Okay, so for that purpose, one second. Okay, we come back to the task qualification here, and within the task qualification, let's go to the check balance task where we have the entity and look into the extraction properties of the entity. So coming to the entity properties, let's go to the instance properties, and here you have the entity extraction logic. It says evaluate unused text from previous utterance. This is the default extraction logic for every entity that you define or build in our platform. What does this mean? It means when an utterance comes from the user, let's say this is the utterance. So the first thing that will happen is intent identification. So the check balance task gets qualified. One of the NLP engines does that. Now, once the task gets qualified, the first entity that comes into the context is account ID entity. Now, what is the type of this entity? The type of this entity is number. The extraction logic says evaluate unused text from previous utterance. So it will evaluate this utterance of the user, okay, and it will see whether there are any values which matches with the type of the entity. What is the type? The type is a number. It sees there is a numeric value which is present in the utterance of the user. What it will do is it will pick up that value and store it within the entity account ID. So that is what was happening. It is automatically picking up the value that matches with the entity type, stores it within the entity, and continues with the conversation. Because once an entity has some value, the bot will not prompt the user for that entity value all over again. Okay, so it is because of this particular extraction logic. The next logic says, okay, now let's understand this a little bit better, looking into the failures that we have. Okay, now here, if you look into the entity extraction side, you can see there are some faults. False means entity extraction has failed. So what was the utterance? The utterance is, I want to make payment for purchases worth $2,000. We were expecting make payment task to qualify. Make payment task has qualified. The payment amount entity should have picked up 2,000 because worth $2,000. That means it is the amount to be paid, but no values were picked up from the utterance. What happened? If you copy this, go back and talk to the bot. So intent identification took place correctly, and the first entity that came into the context is the account ID entity, which has that extraction logic, the default extraction logic, and it evaluated this entire utterance. The numeric value that matched with the entity type was picked up and stored within account ID. So once this value has been used up internally, it is marked as used up for account ID. The next entity that came into the context is the payment amount. This is also a number, numeric type of entity, but it cannot use this value because it has been used up by a previous entity. Okay, so that is what it says over here. If you look into the extraction logic, it says evaluate unused text from previous utterance. Okay, that means if it is used for some other entity, then do not use it for the current entity. Okay, so unused text, this is very important. That is why the 2000, which was used up for account ID, which is the first entity that came into the context, the same value could not be used for payment amount. The other settings are if the same value is to be used again and again for multiple entities, then we go in for the second one. And if we want to say that even if the if the bot has user has specified a value within the utterance, ignore that and prompt the user for the entity value, then we go in for the third one. Okay. But the first one is the default nature. That is, if the utterance of the user contains, values which matches with the type of the entity, pick it up and store it within the entity. This works fine in most of the time, but the disadvantage for this task is both the entities are of the same type. So the first entity which came into the context picked up that value and stored it within itself. How do we change this? How do we tell the NLP, since the numeric value is coming after the word worth, it should be used for payment amount and not for account ID. So now we are going to tell NLP where to look for the entity values. Don't go in for the default behavior that if a value matches with the type, just pick it up, use it, and mark it as used up. Since there are multiple entities of the same type, the position of the value of the entity plays an important role. And by position, what we mean are the words which can come before and after the entity values. And this is where we specify patterns for entity extraction. How do you specify patterns? Come to the entity, come to the NLP properties of the entity, and here you can add patterns for entity extraction. Add a pattern. So the words which can come before or after the entity value. Okay, so usually if the user is specifying an account number, the word from or the word account followed by the account number, right? That is how we use an I want to make a payment from followed by a number, which should be used as the account number. Or I want to make a payment from my account followed by account number. So the word account is coming before the account number. So this way you have to identify possible words or phrases which can come before or after the entity values. The asterisk marks a value which matches with the type of the entity, but the word from has to come before that. Okay. In the same way, we can say the word account followed by a number, then this number should be used as a value for account ID. In the same way, I go in for the payment amount entity, and here also I define some patterns. Okay, so I come to the NLP properties and I say if the numeric value is preceded by worth, it should be used for the payment amount. Okay, or if the numeric value is preceded by for, okay, I want to make a payment for 1,000 rupees. Okay, so that 1,000 is not the account ID, but it is the amount to be paid. How do you understand that? Because the word for is there before the numeric value. Okay, so you can define your patterns like that. The asterisk marks the possible values. You can put words after, before, or words before and after. So the numeric value or the possible entity value should come between those words. Okay. Now, once you define patterns like that, let's talk to the bot once again. So this time you can see the bot is prompting for the account number. It did not pick up this 2,000 and stored it within the account ID because the pattern did not match. And now if I see put a particular account number over here, you can see 2,000 was picked up for the payment amount from the utterance because it is unused till now, okay, because it was not used for the previous entity. So now it picks up 2,000, stores it within the payment amount and completes the task as per the configuration. So that is how you check for entity extraction, the extraction logic. And if you see there are multiple entities of the same type within your task configuration, you can define patterns for better entity extraction. Any questions on this? Okay. So these are the different ways in which you can do the NLP training, a lot of things actually, but as you keep on doing, you will understand what are the best practices. I'll be also sharing documentation with you all. You can go through the best practices when you are training the NLP engine. But it is only after training NLP engine and testing it through batch testing, flow testing that is done with, talk to the bot and utterance testing that you should be deploying the bot to the end user. So let's just quickly deploy once again. My channel is already there. So all I'll do is deploy it once again so that the updated bot is available now. And once we deploy the bot once again, I'm just going to restart this thing, Node.js, because we have made some changes. So let's register those changes and now let's connect to the bot. Okay, so multiple tasks getting qualified due to NLP. So both of these tasks are qualified as definitive matches. So we can select the one. Again, we can change the NLP training to qualify tasks correctly. But whatever the amount to be transferred. So let's say I put $500 to be transferred. It did not ask me for the account ID because it is there in the utterance of the user, and you can see the response coming up. Okay, if you ask other FAQs like okay, so this is a conversation that is taking place. Now, how do you monitor the performance of the bot after it has been deployed to the end user? So you have the analyze section where you have the usage metrics, which will show you the live statistics of a bot. So when you come to the usage metrics, you can see the real-time status, that is how many users are connected to the bot, what channel they are using in order to talk to the bot. Here you can see the total number of tasks completed, the number of conversation sessions. Conversation sessions are like if there is a disruption or a break in the conversation for more than 15 minutes, then it is taken as the end of one session, and after that when the user starts the conversation once again, it is taken as the starting of another session. So when a session is ended, all the context is refreshed. So when you start off again, it is a new session with new data that will be started. Okay, so that is a conversation session. You can filter it on the basis of the date also and the time. Now you can see here the total number of messages and sessions taking place between the bot and the user, the total number of tasks and FAQ. This section actually shows you FAQs, but after 9.0 it is showing a wrong label. That will get, our platform team is working on that. But anyways, so this section shows you the total number of FAQs qualified, total number of tasks qualified on a given date. If there are failures in intent identification, how many failures were there, how many success were there. Then coming over here, you can see total number of times different tasks were requested for within this particular date range that you have selected. Okay, so that comes up. The channel and how many messages were exchanged between the bot and the user on that particular channel. So this is an overview of the conversations that are taking place between the bot and the user. But if you want to see the details, like when you see over here, there were some failures, you would always like to see which utterances could not be processed correctly by the NLP engine, because that is where we need to improve the training of the NLP engine to handle these failures. So once you see that there were failures, if you want to see the details, okay, then come to the NLP metrics part. NLP metrics will have 4 tabs inside it: intent found, intent not found, failed task, and performance. Intent found will show you all the utterances that were correctly matched to intents. If you click on that, you get to see the utterance, the channel, the matched intent. If you want to see the JSON of the NLP analysis, you can see the entire thing over here. If you want to see the summarized view, you can see from NLP analysis section. If you want to see the chat history, that where the utterance came and how the bot responded or how the conversation continued after that, you can see it from the chat history. Okay, so that is intent found. Intent not found will show you the failures. Okay, so you can see over here the failure. Now, why did this fail? Okay, this failed, you should be understanding now. If you come to the NLP analysis, nothing was matched. KG failed because there's a mistake in the spelling over here, personal, but it is personal, and it is a mandatory term. So unless and until that term is present in the utterance of the user, the path is not qualified. So as a result of which, KG could not qualify this particular question. How the bot responded to this failure, click on chat history and you can see the failure response coming up over here. So the next tab, intent not found, will show you all the utterances against which NLP could not qualify any intent. The third tab, failed task, will show you all the tasks which were qualified, but the user did not complete that task. So intent identification had taken place, but the user did not complete it. Reason for failure also comes up over here. Either the user discarded the task, like I had put the discard command multiple times to discard the task, or the intent got qualified, the user closed the conversation window, or the user just stopped the conversation and the break was more than 15 minutes in the conversation where the task was discarded due to inactivity, or maybe the bot was expecting an input and the type of input did not match with the input coming from the user, and after the total number of retries the task was discarded. We have something called interruption, and that can also lead to discarding of tasks. So there are different reasons for which a task may not be completed after it was qualified by the NLP engine or identified by the NLP engine. So you get to see all of those intents which were qualified but finally not completed, and the reason for incomplete task execution, and the point or the node where the task was discarded. You get to see that as well coming up over here. Okay, so that is failed task. And finally, you have the performance tab, which will show you the response time of the API calls and the script notes. So the total time taken by an API call to return response to the bot, you can see it over here. What was the response that is returned? If you click here, you can see the response. So you can see this was the response of the bot. Okay, that was returned. API call that was returned to the bot. Okay, so this is a very important tool, NLP Metrics, which will help you in details to understand what is happening within the bot. Okay, how utterances are being processed by the NLP engine. By default, it will show you all the utterances coming from the developers with talk to the bot. Excuse me, or from the end users after you have deployed the bot. But if you want to see only the end user utterances after the bot has been deployed, click on the filter button over here, and you can filter it on a whole lot of things like the date, the time, the language, the channel, the tasks, if you want to see for a specific task only. And here you have include developer interactions. You can exclude developer interactions, click on apply. You get to see only the utterances that came from the end user and not from the developers with talk to the bot. All these reports can be downloaded for further analysis. Is it clear to you all the purpose of NLP Metrics? If you want to see a visual representation, go in for conversation flows. This will only show you the end user interactions, but you get to see how many utterances led to FAQs, how many utterances led to small talk, how many utterances led to check balance. If you want to see what are those utterances, click on these black tabs. It will show you what are the FAQs that came from the user. If you want to see how the bot responded to it, click on this and you can see the response of the bot. If you want to see how the journey continued from here, you click on this tab. So you can see 33% of the time user continued with the check balance task or the small talk or another FAQ. You want to see what utterance led to the check balance task after this particular FAQ. Click over here. You can see this was the utterance. If you want to see the entire conversation, you can see that. So there was an FAQ before that, followed by the check balance task. So you can see the entire journey of the user, a visual representation from the conversation flows. You can click on each of these buttons to see the entire journey of the user. If you want to see what account ID, you Okay, so you can see this account ID was provided by the user, and this helps you to get an overall pictorial representation of how the conversations were taking place between the user and the bot. But a more detailed analysis can be understood from the NLP metrics. Is it clear to you all? Any questions on this? So these are all the things that you can do. That is, you can test, you can train, you can test, and you can analyze the performance. Now, after you have done all of these things, a few more things before we end the session. One is how you can share bot with your co-developers. Okay, so the first thing is, from your landing page, you first need to invite that developer into your account by providing the email address of the developer. Click on invite members, provide the email address of that developer to invite that developer to your account. Once the developer is invited to your account, now you can share your bot with that developer. So come to manage. Okay, under manage, you can see team members over here. Click on invite, provide the name of the developer over here. Okay, and assign the role. There are two roles available out of the box, that is the developer and the tester roles. These roles define the access permission. Developer role gives full access on the configurations of the bot. Tester role gives only view permission on the configuration of the bot. So a developer can make any changes to the configuration. Though you have created the bot, since you have assigned the developer role, the concerned person can make any changes on the configuration of this bot. Tester role, the concerned person can only see the configurations but cannot make any changes. Additional roles can be defined by the admin of the platform, and then the owners of the bot, like I'm the bot owner because I had created the bot, I can use those custom roles when I'm sharing the bot with co-developers. Okay, but one bot where multiple developers are working on it. Is it clear to you all how you can share bot with others? Okay. If you want to import your bot from one system to another, then in that case, you come to deploy, where you have bot management, and here you have import and export. Click on import and export. So if you want to export your configuration from one system to another, or you want to give a copy of your bot to some other person, then come to export. What you would like to export, the last published version, or after publishing the bot, if you have made some changes to the configuration of the bot, then maybe the latest version of the bot, and you can select whatever you would like to export. Like if you do not want to export the tasks, you would like to export only the knowledge graph. So deselect the task and enable knowledge graph only. So you can deselect whatever you want to export and click on the export button. This will download a zipped file folder within your local system. Once you have this folder downloaded, copy this folder or share this folder on email with the person whom you want to give an export of your bot. In the destination, what you need to do is first you extract the contents from this particular zip file. Okay, so double click on that and extract it. Now, when you extract, it creates a folder, and this folder should contain 3 mandatory files inside it. It is very important to understand this part. Definition file contains the entire configuration of the bot. Config file contains all the variables that are declared within the bot. These variables are, we have not discussed variables because this is a part of the advanced training, but if you are creating variables using those variables in your tile of task configuration, those variables will be contained in the config file. Icon file is the image of the bot. Now, these two files are also mandatory. Even if you don't create variables, you don't attach any icon to the bot, these files has to be there in the export. If any one of these files are missing, your export is incomplete. Make sure you re-export your bot once again. These 3 are mandatory files. Backward compatibility is there. Okay, so from 8.1 into 9.0 is possible. 9.0 to 8.1 won't be possible. Okay, backward compatibility is there. Now coming here, so these three should be there, these three files, and once you have that in the destination, the next thing that you can do is import and create a new bot. So you come back, if you are creating a new bot out of that export, come to your landing page, and here when you click on new bot, say import a bot. Okay, so when you click on import a bot, give a name to your bot. Okay, test it, give a name to your bot, and then come here. Okay, bot definition file, click on choose file and select the definition file. Okay, so come to that particular folder, your definition file over here, config file, click here, select the config file. If you want the same icon, you can select the icon file also. If you want a different icon, you may not select this icon file. These two files are mandatory. Icon file is optional, but icon file has to be there in your export. Okay, whether you attach an icon or not does not matter. Okay, so now you can click on import. You will see a new bot created with the same configuration that you have exported. Okay, so you can see the same tasks over here, the total number of questions, and the paths and all are from the FAQ, the small talk section, the digital form, the training, NLP training. Only channels are not part of the export. So channels has to be enabled separately for every bot. Okay, so you cannot export the channel configuration. So that is not there within the export. So this is creating a new bot from the export that has been given. Is it clear to you all the entire process? Okay. You can also import within an existing bot. At times, somebody else has created the knowledge graph, something part of the configuration. You want to import that configuration within your bot. So in that case, come to deploy, come to bot management, you have import export. And in the import section, select your definition and the config file. Full import means the current configuration of the bot will be replaced with the configuration that you are importing. Okay. Incremental import, you can select what you want to import from that export file. So if you just want to import the knowledge graph, then deselect everything, have knowledge graph selected, and start off with the import. You have to select the definition and the config file. So from the export, only the knowledge graph section will be imported within your current bot. So this comes into play where different developers are building different parts of the bot, and finally you want to get all of those things into a single bot. Then you can import within your existing bot. Okay, so that is importing within the bot. Any questions on this? Finally, bot versions before we end. So whenever you publish a bot, whatever configuration of the bot you're publishing, that gets versioned. Okay, so that is the auto version that gets created. But as a developer, you can create your own version also. So like I was telling, let's say today you have a good working, configuration. And before making any further changes, you would like to save this configuration so that if anything goes wrong after the changes, you can always restore this version back. This description should be actually a detailed description of what is the configuration that you are storing under this version. Okay. Now, once you do that, click on new bot version. That will create a version for you. Now, once the version is created, after this, if you are making some changes, now let's say I come back over here, come back to a dialog task, and let's make a change in the dialog task. Okay, one of the tasks, a small little change. Now there is a feature where you can invoke another task from the current task. So let's say, how do you invoke? So it might be a requirement, at times, that from the current task, you want to invoke another task. So let's say from the check balance task, I want to invoke the make payment task. Okay, anywhere. Okay, any other pre-configured task which is there within your bot, you want to call a particular task from your current task. So click on this plus sign, you go to the dialog task node, which will list out all the tasks for you over here. Select the task you would like to invoke. So it was basically doing what? From the check balance task, it is invoking the make payment task. Okay, this is invoking the make payment task. So this is a change that I have made after I have created the version. Now, if you're not happy with the changes, you can continue with making all the changes as you want. But later on, you realize all the changes that you have done were incorrect. You want to roll back those changes. So come back to deploy, come back to bot management, to versions. And this was the version I created before I started the changes. So all I need to do is come here and click on restore. It will restore the configuration that is stored under this particular version. Just give me a few more minutes. I'll just complete the session. So if I come back to the check balance task, I had used a sub dialog node to invoke the make payment task. That was the change that I had done. Let's go back and you can see the changes has been cancelled and we get back the task as it was before the changes were made. Okay, so whatever is the configuration you have within that version, that will be restored. Is it clear to you all? Any questions on this? Okay, and finally, you can delete a bot if you have not published that bot. After publishing the bot, it is not possible to delete the bot unless the admin of the platform suspends the bot, and then as a owner of the bot, you can delete a bot. Okay, and change logs will show you the list of all the changes along with the name of the developer and the date and time on which that change had been made. Okay, so that is the initial part of the bot building procedure where we started off with storyboard. Let's quickly recap the topics that we did in this training session. Storyboard, designing conversations, dialogue tasks are the conversation tasks or the conversations that can take place, knowledge graph, FAQs that you want to add into your bot, small talk, the general conversations. Then we had digital forms, we had data tables. Then today we started off with a small little changes on the dialogue task followed by NLP, where we looked into the ML training, the FM training, the KG training, the working of the ranking and the resolver engine. Then we went in for testing the bot with utterance testing, flow testing, that is talk to the bot, which we have been using since yesterday, and batch testing, entity extraction property of the NLP, how we can fine tune that with patterns if there are multiple entities of the same type. Then we looked into publishing a bot yesterday itself by adding a channel, analyzing the performance of the bot with usage metrics, NLP metrics, and conversation flows. And finally, how we share the bot, import, export a bot, look into create bot versions and restore bot versions, delete, and look into the change logs of the bot. Okay, so this should give you an end-to-end understanding on how to build a bot, share your bot with your co-developers, export, import bot configurations, deploy your bot to the end users, train the NLP engine, and test the bot. Okay, any questions on anything that we discussed in this training session? Okay, so today before the end of the day, I'll be sharing the recording, along with that your post-training assignment. Please, all of y'all, try to do that assignment, though many of you might get the same assignment if you are working with the same organization. But the assignment will help you to put into action whatever we have discussed in these 2 days. Okay, so it will give you a good understanding of how to do the bot configuration. So try it out. If you face any challenges, mail me your questions. Even if I don't respond immediately, I'll definitely look into your questions within a day and respond back to you all. So complete your assignment within 2 weeks. And after that, export the configuration to me for evaluation. And once we evaluate, we will certify that you have completed the basic training session. And then only you are eligible for the advanced training. Any questions on that? Okay, so that brings us to the end of